Hey there, welcome to this Python 101 course. My name's Olaf Paulsen, and I'm really excited to get to guide you through the basics of the Python language here on Scrimba. Now, not only will you be learning the most popular, but also likely the most versatile programming language right now, Python, but you will be learning on the Scrimba platform, which will take the tutorial experience to a whole new level. I love it, and I'm hoping that you will too. So why should you learn Python? Well, Python is a really versatile and really easy to learn language. Part of the versatility comes from it being a bit like a smartphone, where you can access and use any of the 150,000 or so apps in the App Store. And those modules will help you fix more or less anything you need solved without much effort on your part at all. Python is also very easy to write and forgiving as programming languages go. And to be frank, it's probably the easiest language to get started with, as it's even more like regular English than most other programming languages. If you want to create a script to back up files, or check something on a web page every 10 minutes, or create a face recognition implementation using machine learning, or land your first job in development, then Python is for you. Easy access to data on the web. Sometimes people refer to Python as being made for the web, and this mostly means there are lots of tools that you can use to get data from the web and websites, or interact with other applications on the web, again with very little coding effort on your part. Python is very often used as the programming language when working with AI and machine learning by data scientists and researchers, and there are many reasons for this. But on one level, you need to remember that if you want to work within this area, Python is almost a requirement. And if you ask me, it's probably the easiest language to get started with. So in this course, we're going to work together to take you from a beginner to an intermediate Python developer. So you can start experimenting and using all the available tools, or maybe to prepare you for a more comprehensive programming bootcamp or a course that you want to take. We're going to take you from 0 to good, and if you want to get to great, you just need to practice more. The course consists of interactive tutorials where I walk you through various concepts, and then exercises where you can practice these concepts. But don't for a second think practice is only in the exercises. You can and should practice and play around with the code as much as possible. Learning is supposed to be fun, so just have fun with this. And that is one of the really great things about Scrimba. You can pause any tutorial whenever you want and start playing with the code. You can add, remove, run, or fork the code and save it. Anything you see on screen, you can modify. And all this experimenting is what's going to make your Python programming muscles strong and really cement the knowledge that you get. So be curious and interrupt me as much as you want. I won't mind at all. As long as you're learning, I'm happy. In the end, how much you learn is really going to be up to you, and you'll get out of this course what you put into it. If you just watch the tutorials without doing any of the coding exercises or trying out the code that you see, you're not going to get anywhere near the full learning experience that I think you expect. So commit to your own learning and work through all the exercises and play around with the code in every tutorial. That is going to make you a great programmer. So as a bonus to this course, we've created a Facebook group for you. It's called Python 101, and you see the link right here that you can click on. Otherwise, search for Python 101 and you'll find the course on Facebook. It's a social learning group where you can learn with others who are doing the course just like you, and you can do more exercises and learn even more. I'm hoping to see you there and interact with you directly. So what are we going to learn in this course? We're going to learn basic syntax and outputting data and Programflow. We're going to work with text using strings and store data in variables. We're going to learn how to do math in Python with arithmetic operations. Then we'll look at lists, tuples, sets, and dictionaries for storing different types of data. We'll learn how to control how your code runs with conditionals and if and elif statements. We'll teach you how to use loops, both while and for loops. You'll learn how and why to use functions, return statements, why and how to comment your code, and what to do when you encounter errors. You'll learn about objects and classes and even about inheritance. And you'll even learn about list and dictionary comprehensions and lambda functions, sometimes called anonymous functions. Ooh. To prepare for your next step and open up the Python world of opportunities, you're going to learn about modules and how to use them in your code. You will also get plenty of exercises and some projects and other bits and pieces. So it's time to meet your instructor. That's me. My name's Olaf Paulsen. I'm Swedish, and I have a passion for education. When I'm not doing this, I'm the advocate for Khan Academy in Swedish. That means I do as much as I can to make sure that we have a Khan Academy in Swedish. That's a not-for-profit project I've been working on for a long time, and I will probably continue quite a while longer. My background is mainly from the finance industry in investment banking, portfolio management, and also running development teams. And the programming I've done has mainly been around writing algorithms. If you want to reach out and tell me how you found the course, you can do so on Twitter or in the Facebook group. Now with that, there's really only one question left to ask. Are you ready? Then let's get started and see just how deep this rabbit hole goes. I'll see you in the next tutorial. Alright, so I'll welcome you to the Python 101 course once more. And I thought I'd tell you how we get a backend language like Python to run on a front-end platform like Scrimba. And as usual, it's an add-in or a module that comes to save us. And in this case, we'll find it in the index.html file. So here in the HTML file, we have the Brython plugin. Now normally we run this Brython minimum.js. And what it allows us to do is to write Python code that then gets recompiled into JavaScript and can then run on the Scrimba platform, or I guess many other platforms. And this is the one we normally use. When we want to do more advanced stuff, or if you want to experiment on your own, edit out and enable this script, the one that has the Brython standard lib. That has more functionality and is something we're going to use when we import modules, for instance. And if you take a look at the versions, of course, by the time you're looking at this course, there might be newer versions, and with really bad luck, maybe some of the code we write isn't going to work on later versions. But anyway, you can do this. You don't have to, but you can. There are also a few oddities that I thought I'd go through that you're going to encounter through the course, and they are not many, but there are at least two. So the first one is the input box that we're going to use when we get user input is, in this case, really the JavaScript prompt. And for some reason, the screen capture doesn't capture that, so you can't see it. If you run your own code, you can see it. And what it looks like for me when I talk about it and I say, hey, I'm getting an input box and you can't see it, is this. And you'll see it as well when you run the code locally, but you just won't see it when I'm running through the code in the tutorial. So bear that in mind. Another thing is that the Scrimba mini browser sometimes hovers in the corner in some tutorials. You don't have to worry about it. I'll show you what I mean. We're talking about this little browser, this guy right here. So he's going to be hanging out down here in the corner just to be out of the way. And in some tutorials, you won't even see it. But again, don't worry about it. So that's how we get Python to run in JavaScript and in Scrimba, and are able to do this awesome course for you. So with that, let's get cracking with the first tutorial. Okay, welcome. It's time to get started. I hope you're as excited as I am. So let's start talking about programming languages very briefly. So when we program, we're giving the computer a bunch of instructions. And the programming language we're using has different special words that mean different things. Luckily, most languages have somewhat similar words and ways of writing. So they're often more like dialects than totally different languages, which is good if you want to learn multiple languages. So in Python is one of the more simple languages to learn. So that's great, right? So let's get started. So when we write our Python code, we will often want to see if it's working, if we're getting the numbers that we're expecting, and so on. And the way we often do that is to output data down into the console down here. Now, there isn't any data down in there right now, but there will be soon. And to do that, we use the print command, which looks like this. And then inside the print command, we put some quotation marks, either single or double, and then we type whatever string we want to output. So in this case, we'll say, welcome to Python 101. That means you. Okay, and if we run this, we'll see that it outputs the text without the quotation marks and without the print around it. So the print statement is a way to tell the computer, please print the stuff that I put inside the quotation marks, okay? And when Python reads our code, let's copy this, it does it in the same way that you read, at least if you read Western languages. So it reads top to bottom and left to right. So if we add a 2 here and run it, you'll see that we have 2 rows. We have welcome to Python 101, and then the second row is the second row that I typed. Now, if I move these so that I put this row above the first one, you'll see that it turns around. And that's important to remember, because when you're writing code, you want to make sure that you're writing in the same direction that you're reading, and also that the computer is reading, because otherwise you might be trying to use something that doesn't exist yet. So for instance, if we create a hammer, create hammer, copy it, and then afterwards we use the hammer, that will look quite good. So first we create the hammer and then we use the hammer. Now it would get really weird if we tried to do this. First we use the hammer and then we create the hammer. use hammer, create hammer. That's kind of impossible, right? Because you can't use the hammer until you've created it. So let's get rid of that. And then when you're executing, you can either press this green button over here to run your code, or you can use the Control S shortcut, or on a Mac, the Command S shortcut. Now, as your very first assignment, I want you to write a print statement that creates some nails in the right place, and then modify the use statement that we have here so that we also use the nails with the hammer. So give that a shot, and I'll be back with a solution shortly. Great, so did you try that? I hope you did, and that goes for all the exercises in this course. When there's an exercise, try to do the exercise. Don't just wait for me to come up with the solution, because you're going to learn so much more, and it's going to stick for so much longer, and it'll be so much more fun. So here's a way to do this. So let's copy this. And always in programming, there are many ways to solve the same problem. The way that I show is just going to be one of many ways of solving a problem. And that's something to keep in mind. So just because I write it doesn't mean that it's right. If you solve the problem in a different way, kudos to you. You've solved the problem. All right, so let's create some nails. And then let's use hammer and nails. Let's run that. And there we go. We created nails, create hammer, and then we use hammer and nails. Awesome. I'll see you in the next tutorial. When we're programming, we often work with a lot of data. Sometimes we want to save this data, or maybe we calculate some stuff that we want to save and use later. For that, we use something called variables. And a variable you can view a bit like a box with a label on it. Imagine that you have all your shoes and you put them inside a brown box, and you put a label outside on the box that says shoes. And every time you ask the computer for your shoes, it gives you the box with all your shoes in it. That's basically how a variable works. So here's a story we print about Eric. So his mother is getting this note from school, and Eric had a plan to go to a party this weekend. And he's failing 6 subjects. Eric will need to redo 6 courses. Eric is doing well in geography. Well, that's nice, but I guess he's not going to get to go to this party. So what can we do as his slightly unethical friend to help this out? Well, we could rewrite the note that he's getting home. We could, for instance, go in and change these things, like we could change the 6 to a 2, we can change this 6 to a 2, and we could change these things. But let's say this was a really, really long letter, or maybe it was a whole book, and we want to change the name of a character or something like that. So how would we go about doing that? Well, this is where variables come in handy, and concatenating strings. And I will show you how to do this. So let's start by creating a variable. And when we create a variable in Python, we use small caps. So, failed subjects, we'll call the variable, and we'll set that equals to. And when we assign variables, the equal sign is not the kind of equal sign that you use in math. It's actually an assignment operator. So a better way to see it, instead of saying failed subjects equals 6, you should see it as failed subjects gets the number 6. So we put the number 6 inside our failed subjects box. Okay, so that's how that works. And then we are going to put that inside this story. How do we do that? Well, we start by closing off this string here using a plus sign, which tells the computer to add on whatever we put after that. We remove the subjects, and then we'll copy this because we're lazy. Don't want to make mistakes. Failed subjects. And then we will finish off with another plus sign, and then the end of the sentence, which should have a space. And then we'll copy this part here, and we'll paste that into the next one where we have 6 as well. Add a space. There we go. So now we have changed the strings to contain the variable that we're using. So let's try and run this and see what happens. So we still get the same result because we haven't changed the variable, but let's change it. And we see here that the failing 6, we should have had a space there. So let's change it to 2. That's a lot better, isn't it? Run it again, and now we see that Eric is only failing 2 subjects, but maybe it's still not good enough. So we should maybe change this further. So it turns out Eric has a brother, and his brother's name is John. Now, unfortunately for John, we're this unethical friend, so we're now going to put the blame on John. So let's take this, copy it, and replace this Eric with failed subjects. And you're saying why failed subjects? We're going to change it to name. There we go. Do the same thing with this one. Actually, we don't need those. And then we place it here as well. There, so what we've done is replace these strings with the variables that we just created. So Eric should now have turned into John. Let's see if that works. So now it turns out that Mrs. Badger has the message that your son John is failing 2 subjects. John will need to redo 2 courses, and John is doing well in geography. So this is looking good. I think we're going to be able to get Eric to come to that party. However, we're not quite happy yet. Our evil friend isn't done yet. So now what we can do is variables can be reassigned at any time during your program. So we can reassign the value of name down here to be Eric. And what do you think is going to happen now? Let's see. Exactly. So things are looking a lot better for Eric, and it looks like he might be going to that party. So I'll see you next time. Let's talk about the basic data types of Python. So in our previous program where we learned about variables, we ended up with this code. And all the blue parts here are a data type called strings. And the way you tell a string is by the fact that it's surrounded by 2 quotation marks at the end. It doesn't matter if you use double quotes or single quotes. They are equal in value. So this is a string, and even the space here is part of the string. Basically, that's alphanumeric characters you can get from the keyboard, and they are treated as characters. They're not treated as numbers. If you want a number, you input a number, and you just don't use the quotes. So that is now something called an integer. So an integer is a whole number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of course, sometimes we want to have, or most of the time, we might want to have decimal numbers, and those are called floats. So now I've turned this integer into a float, a floating point number. Another type of data that we have is something called a Boolean. And a Boolean is a data type that can take on the value true or false, only those 2 values. And we use those a lot in programming when we want to control how our program runs or when we want to check for different things. We don't use them that often in real life, but we use them a lot in programming. So an example in this case might be is going to party. Spelled correctly. There we go. Is going to party equals, now in the beginning of our story, that probably would have been false. At the end of our story, it probably would have been true, which was better for Eric. Not so good for John, because he probably had false. Until Monday, at least, when his mother found out what actually happened, and Eric would be in real trouble. But that's a different story. So when we name variables, we obviously shouldn't do what I did there. It needs to be one word, and we use underscores between the words and don't use capitalization, at least in Python. And you can also use camel casing, which would be this type of writing, where you capitalize every new word. But the standard in Python is to use underscores between the words. So there we go. Now, I said that it doesn't matter if you use double quotes or single quotes, and that's correct. And then there are some cases when you get into trouble and don't know exactly what you're going to do and how to handle it. And here is an example of that. So let's say you have a variable where you want to store the word it's. So you write it's, and if you take a look at the code now, only the IT has turned blue. The S is white, and it shouldn't be, because we want all of it to be the string. But Python is not understanding us, and that's because this thing is being interpreted as the end of the string. So we need somehow to tell Python that it's not the end of the string, that it needs to use the quotes at the end as the actual end of the string. So the way we can do it here is to change this to double quotes, and at the end, double quotes. And now it's seen as a string, and it will be interpreted that way. There's another way to do it, which is called escaping. And there's an escape character in most programming languages, and it's the backslash. So if we were to do the same thing, so here, copy that. This time we want to use the single quotes. We don't want to change the double quotes. So it's now broken again. And by inserting a backslash, tells Python, the character I have after this, I want to actually use the literal character, nothing else. So this tells Python that after the backslash, I want to use the character that you see. Don't interpret it as something smart, just do what I tell you. So that's how escaping characters works. So when you're working with this, you sometimes want to know what data type you're dealing with. And there's a command for that called type. And you input whatever variable you have into it and you get an answer. So I'll show you an example right here. So here are 4 statements, and we'll get rid of these for the moment. Now if we run these, we'll find out what type we're dealing with. So we have a string, hello, we have a number, 1, we have another number, 1.64, and we have true. So how are those interpreted? Well, the first one is a string, the second one is an int or an integer, next one is a float, and the last one is a Boolean. So now we'll go back to our previous program, paste that back in. Remember I said that you could use the numbers? Well, you can't mix numbers or different data types any way you want. There are some rules around how you can do that. So for instance, you can't put numbers. So if I make this a number, you can't put that inside the string, or you can't mix it with the strings. So the way to get around that is something called typecasting, or casting or changing a type. Basically, you're telling the type. So in this case, it's an integer. I'm telling the integer, hey, integer, I don't want you to be an integer anymore. I want you to be a string. And the way you do that is by using the shorthand, str, and you encapsulate this like that. And we do the same thing down here. Now, it will use the actual number. So let's run that. Now, if I don't have this casting, if we remove this, it fails. It actually says it can't convert int to string implicitly. So I have to do it explicitly. String to change the integer to a string. And the same thing would happen if I put this like that. So that was a run through of data types and typecasting, and I'll leave you with a few examples. So here, if we cast 1 into an integer, we will get 1. If we cast 2.5 into an integer, we'll get 2, so it removes the decimal. If we cast the string 3 into a decimal, we'll get 3. And here's a special case. If we cast 3.4, the decimal in string format, into an int, it's actually going to return an error. So we'll come back to that a bit later. And if we cast 1 into a float, we'll get a decimal number, so 1.0. 2.5 into a float, 2.5. 3 as a string into a float becomes 3.0. And 4.23 into a float becomes 4.23. So that's the case we had up here, but here it works. Then if we cast 80s, the string, into a string, we of course get the same thing. 22 into a string, we get 22 as a string, so it's no longer a number. 3.01 becomes the string, 3.01, again, it's no longer a number. So let's try and run these and see if the results work. And they do. So now let's go back to the one we had up here. So it turns out that you can't actually do this. If we run it, error. And the reason is this is a decimal string and we're turning it into an integer, and that's not an allowed operation. You can do it with a float as we did down here. So what you can do to handle this is to first cast it into a float and then cast it into an integer. And then we add the variable, C1, and we see that we get another 3. So I hope you enjoyed that, and I'll see you next time. Hey, and welcome to this exercise on variables and data types. So what we're going to do this time is try to create an app. And the app is, say, for a hardware store, and the hardware store needs to keep track of a few things. So I'm going to paste that in here as comments, and that will give you a chance to see what comments look like. So here's the text, just to show you they are comments because they start with a hashtag. So now it's a normal text, now it's a comment. So create appropriate variables for item name, the name of whatever the item is, the price, and how many you have in stock. So that's your job. So create 3 variables and choose the right data type for them. Okay, I'm hoping you tried that exercise. So now I'm going to give you one alternative to how you could do this. So let's start with the item name. So why don't we just call that item name? And that will get, we'll give it a name, which should probably be a string. So let's say widget. That's the fantastic name of our item. So next step, the price. Why don't we call that price? Don't have to make it harder than it is. And the price could be maybe not always an integer. Maybe it's going to be some decimal number. So let's make that a float. And the way we make it a float is just simply to put a comma in it. That automatically makes it a float. And the next step, how many do we have in stock or our inventory? Let's call that inventory. And in this case, we can't have half ones or whole ones because they're widgets. So let's say that's an integer. And let's just say we have 100 of them. Now as a next step, why don't we try and print this as well? So let's print all of them. Let's say print item name, comma, price, comma, inventory. What do you think that's going to print? Let's find out. We get widget 23.5 and 100. Now another thing we could have done is to use a Boolean. So we could have said is in inventory and set that to true. And then we could have had a flag that told us whether or not we had any inventory at all. But of course we wouldn't know how many we had in inventory. So that would be sort of useful, but not entirely. So that covers that exercise. I hope you enjoyed it, and I'll see you in the next tutorial. Doing basic arithmetic operations in Python, and for that matter any other programming language, is very, very common. So having a firm grasp on how to do it is definitely a plus plus, just not in Python. After this short tutorial, there's a good chance you will be very awesome at this. Are you ready? And if you just heard me say plus plus before and have absolutely no idea why I said that, or perhaps racking your brain, don't worry. Eventually that penny will drop, Google might be your friend, and you'll realize just what a lame pun that was. And if you did, well, I guess that's just time you'll never get back. Sorry. Anywho, here we go. So let's paste in a few examples. So here we have two variables. A gets 6 and B gets 2. And then we're going to print out the results of various things. So the first one is addition right here. And you see in Python, we write addition as A plus B, and we would expect the result to be 8, right? Subtraction, we write, as we would expect, A minus B. Multiplication, A star B. Division, float division, this is what we would normally call division. So if you divide 3 by 2, you get 1.5, A divided by B. Then we have something called floor division here. Now, floor division is sort of an artifact from older versions of Python, where it used to be that if you divided 3 by 2, you would get the answer 1, not 1.5. So floor division actually does that old type of division. So if you divide 3 by 2, you will get 1, not 1.5. Then we have modulus, and modulus isn't one of the transformers. It's actually an operation we use in computer science and in math that gives you the remainder of the division. So for instance, if we divide 6 by 2, we get 3, and the modulus will be 0. If we divide 7 by 2, we'll get 1, because if you divide 7 by 2, you'll get 2 groups of 3, and then you have 1 left over. So it's that leftover remainder that's shown in the modulus. Then we have exponent, which is a to the power of b. All right, so let's run this first, and then we'll change the numbers and show you some interesting stuff. So here we go. The addition is 8, the subtraction is 4, the multiplication is 12, division 3.0, division floor, same, 3, the modulus is 0, and the exponent is 36. So that's to be expected, right? But it's not very interesting because the division floor and the modulus are both showing the same result or nothing. So let's change the numbers. Let's say we have 10 and divide that by 3. Now we'll see some of the more interesting bits. So now the addition is 13, subtraction is 7, multiplication is 30, the division is 3.333333, and then weirdly, the last number is a 5. Don't ask me why it's like that. Floor division turns out to be 3. The modulus is 1, so we're dividing 10 by 3, and the remainder will be 1, right? Because you have 3 groups of 3. And the exponent, when you do 10 to the power of 3, that's 10 times 10 times 10, is 1,000. And those are basically the arithmetic operators that you need to understand to be able to become a master of Python. You might need to learn some other stuff as well, but we'll get to that. Talk to you later. Okay, time to talk about strings. So we use strings a lot in programming. We take them apart, we put them together, we create new ones, we delete old ones, just lots of things. And I'll introduce you to some of the basic concepts when it comes to using strings. So as you see, we've already run this statement. We have a message, welcome to Python 101 strings. Then we've run the print message and you see the output down in the console. So one of the things we can do is print a message multiple times. And you could do that by concatenating the message. So just by typing a plus sign and then the message again. So if we run that, we'll get the string, just the two strings put together with no space in between them. So that's one way of doing that. You can achieve exactly the same thing by multiplying the string, which seems a bit weird, but if we multiply that by 2, we'll get exactly the same result. So no difference, the strings are just put together. So there's another way we can do this, and that is to separate these by a comma and say message, message. So what's going to happen then? Now you see a space has been inserted after the strings. So the comma does that. And this is actually a statement you can use inside print, and I think you use it in input as well. But I'm not sure if you can put together strings in a variable by doing this. But at least now you know 3 different ways of multiplying strings. So there we go. So another thing we might want to do is change the casing of the string. So there's some different ways we can do that. We can say upper, which will, and then parentheses, nothing inside the parentheses. If we run that, the whole string will become uppercase. And you might guess that we can do the same thing by saying lower, like that. And that is going to give us the whole string in lowercase. But we can do more. We can say capitalize. It will actually make sure that only the first word in the string is capitalized. So then we get that result. So as you see, it even changed the capitalization of the word Python. It's now in lowercase, but the first letter, which was previously in lowercase, is now in uppercase. Now, if you wanted all the different words to have uppercase, there's actually a function for that as well. And that function is called title. That will give us this result. So each of the words are capitalized. Now it actually fails sometimes. For instance, when we have an apostrophe in what we're writing. So I'll introduce one up here. So let's say we have it's, and now I've messed up the string as well, so I need to introduce an escape character to make it easy. There we go. So if I run it now, and you take a look at the result, you'll see that welcome to it's, and then there's an apostrophe, and it interprets the S as a new word. So the S also gets capitalized, which is not optimal, but it sort of works, except when you have that situation. Okay, so those are some basic things that we can do with changing the aspects of the string. So let's remove those, and let's try some other stuff. Let's find out some information about the string. So for instance, let's say we want to find out how long the string is. And we'll also get rid of this. It's just going to be annoying. There we go. So print message, and what I want now is to find out the length of the message. There's a command called len, which is short for length, which will give us the length of the string. Let's run that. It's 30 characters long. Great. So another thing we can find out is we can count the number of instances of a certain word or a letter. And we do that by the command count, and that looks like this. So let's say message.count, and what do we want to count? We want to count the instances of Python. We'll run that. How many instances are there? There are 0, and that's because it's case sensitive. So it's now only looking for lowercase Python. So if we change it to uppercase, it will find 1 instance. Now, of course, we could search for something else. We could search for just the letter O and see how many we find. There are 3 O's in Python 101, or in the whole string. Great. So that's how you measure the length of a string, and then how you count how many instances of something you have in the string. But we can do more stuff. We're going to go into something called slicing strings. Slicing. So slicing strings is getting parts of a string and returning them. So let me give you an example. So the way strings in Python are numbered is in the following way. The numbering starts at 0. So the first character is 0, or the first position. Then it's 1, 2, 3, 4, 5, 6, 7, 8, and so on. And it's the same thing for lists in Python. So to access this, first we'll need to comment this out so that it doesn't get run. So the way to access this is to use square brackets. I'll input square brackets, number 0, and that will give us the letter W. If I use number 5, it will give us M, because that's the 6th position, which is number 5. Now you can also use negative indexes on this. So for instance, if I take -1, this will give me the last character. That gives me S. If I take -3, it will give me the N. So that's second from the last, as it starts at -1 is the last one. There's another way to use this. So if I say 2, the colon will tell Python to grab everything after the number 2 string. So in this case, if I do this, I will get almost the whole thing. I'll come to Python 101 strings. If I specify an endpoint, now it gets a bit more interesting. So let's say 15, see where that winds up. Welcome to Pyth. So let's do another one that we can count. So there. So now I've asked for 2 to 7, and 2, that specifies the second position. 7 is the 7th one, but it's not inclusive. So it takes up to that, but it doesn't actually take the 7th one, as you'll see from the LCOM that we have. We have position 2, 3, 4, 5, and 6, but not number 7. That's kind of important to keep in mind. And then lastly, if I turn it around, remove the 2, Python will now assume that I want everything starting from 0. So this will give me the whole string up until the 6th one. So welcome. All right, let's start with that and continue with some more string information in the next tutorial. See you then. Okay, great. Welcome to your first exercise. So here's the exercise. From the string, welcome to Python 101 strings, extract text and then print a new string that says one welcome ring to Tyler. Every first letter in a word should be capitalized, so it should be in title format. And then the second exercise, which we haven't gone through, print the same string backwards. Google's your friend. So give that a shot and see how it turns out. I'll come back with the solution in a second. Great, so did you try that out? Let's see what we can do. Let's start by creating a variable for our new string. So we'll call that message1. And then we're going to print message1 as we work along so that we can see that we're doing the right thing. So let's start concatenating a string. So we'll start with message. I think we're going to be using that a lot. So message, what's the first thing we need? We need the number 1. So that's at position 17, maybe. Let's see. We'll print. That was empty. So that means it's probably 18. So there we go. Great, 1. And then we need to add to that a space, since we want to have 1 space. Next up, we want welcome. And we actually have the word welcome, right? So we can use a slicing method here. So message, we want to slice from the first letter to the 8th. The reason we want 8 is because we also want the space, so that we don't have to add a space here before the next one. So then we grab another slice. Now we want ring, and ring actually exists as a word inside the word strings, right? So we can grab that. So that's if number 1 is 18, it's 19, 20, 21, 22, 23, 24, 25. It starts at 25 to 29. Let's check what we have so far. 1 welcome ring. We add some more. Now we need to add a space because there wasn't one there. And then we add the word 2, which we find at position 8 to 11. 8 to 11. And actually, if we print that, we'll see it works. But do we really need this space? We could do start at 7. And we get the space before it too. So there we go. Then we have to pick the different letters to create the name Tyler. So let's do that. So we've got message T is in position 13. We've got Y in position 12. Then we have L in position 2. E in position 1, and the R we can grab from the 5th position from the end. So plus minus 5. Let's try out our string. 1 welcome ring to Tyler. Awesome. And then we need to capitalize it. So let's do that. How do you do that? Well, you say title. 1 welcome ring to Tyler. Fantastic. And then as our second exercise, we're going to print this string backwards. So how do you do that? Well, there's a slicing trick, and it's really simple. Just haven't gone through it yet. So let's try it. It's print message 1. And here comes the slicing trick. Colon, colon, minus 1. That prints a string backwards. So let's do that. And let's also make it in title format, so everybody's happy. And there you go. Now you've learned a new trick on slicing strings. Talk to you later. Okay, let's continue working with strings. So the first thing I thought I'd show you is how to do multi-line strings. Now, unfortunately, this is one of those things that Scrimba is not going to support, or rather maybe it's the Brython plugin that doesn't support it. But what you do to get a multi-line string is something along these lines. You use triple quotes to start the string, and then you just use return to break the lines, and then you use triple quotes at the end. And if I now execute this, it's actually just going to print on one line, which is not at all what we want, but it's what we get in this version of Scrimba. So you'll just have to trust me on this and maybe go to repl.it or some other place and try it in a real Python environment, and then you'll see what it looks like. So let's go back to where we were. There. As our next step, we're going to try some find and replace. So we'll start with find. We'll go in here and we'll say print find. So now we're looking for the H character. So we find it the first H at position 14, which is the 15th position. So that's one way we can then later reference it. Or if we look for instance, Python, it starts at position 11. Okay. So the other thing we can do is actually replace. So let's go in back here, change the find to replace. And now we'll replace Python with the syntax. Now it takes two parameters. The first one is what we're looking for. The second one is what we want to replace it with. So we'll replace it with Java. We'll run that. So we now have a string that says, welcome to Java 101. Or we could say C. So that's how you use replace. Now, one thing to remember about this is that strings are what are called immutable. So that means that you can't change them when you've created them. So you need to save them into a new instance. So if I want to save this result, I can't save it in the existing message one. I can create a new one, or I can just set it to a new variable. So I could do this, message1 equals message replace Python with C. Then print message1. So if I run this, we now get the same result. We need to save it into a new variable. We could have also saved it into the same variable like this. That would also work. The next thing we're going to try out is something called membership. So let's look at the following. So now we're going to print and we'll say Python in message. Now what this is going to do is check if Python exists in message. Let's try that. It prints true, so it does exist in there. If we want to check if it doesn't exist, then we can say not in message, and we'll print false. And lastly, we'll cover something called string formatting. So previously, you remember we concatenated strings. Now I'm going to paste in an example here. So we have a variable that has the value Terry. We have a color, red, and then we've concatenated a string. And then we'll run a print statement as well. So we'll run print message. So what does this give us? It says Terry loves color red. Now when we get longer strings that we concatenate, it can get very messy to keep track of what's where. So there's a function in Python that allows us to format strings in a nicer format and make it easier for us to read and not make as many mistakes. So I'll show you that. So we can achieve the same result with a different formatting that looks like this. So we'll create a different one called message1, and it starts with an F. And then we start a string. In this case, we start with the square brackets, and then what we do is we take our variables and insert them in curly brackets. And this makes it a lot easier to read, and we don't have the plus signs and the extra quotation marks floating around the string. So here we have name, loves the color, and then new curly brackets, color, lower, because we have those in capital letters, or maybe we don't, but we don't know. So we want these to be in lower. And let's make the same change up here. There we go. And then we'll run another print statement, print message1. As you see, this gives us exactly the same result. And now we just have the Terry bit to change. So we've got name here. And what do we want to change that to? So here's your first assignment on this. Make the name Terry capitalized. So did you try that out? So how do you do that? Well, here's one way. Run it. And there we go. So those are some further things you can do with strings. I'll talk to you later. How do you capture user input? Well, stick around and I'll show you. So now we're going to try some user input, and actually Scrimba doesn't support the input box properly, so you won't see it in the screencast. I mean, I see it on my computer when I run this, and you'll see it if you test the code on your computer, but you can't see it in the screencast. So you'll see me writing something, and then something will pop up in the console at the bottom, but you won't actually see the data that I input into the box. The way you can see it is just to pause or stop and try the code yourself just after or before I do, and then you'll get the same result and you'll see the pop-up box. Fortunately, not my fault. I'm sure Scrimba will handle it at some point when they start supporting Python properly, but they don't, so we can't really complain either. So here we go. So the first thing we're going to do is we're going to ask our user for their name. So we create a variable, name gets, and then we type input, then we'll type something. Let's try, what is your name? Question mark. There we go. Maybe a colon as well. Now when I run this, I'm going to get an input box where I can input my name, which you won't see, and then it will print name. Let's see how that works. So I now see a box and I'm typing a name. Let's pretend that my name is Eric. There we go. Eric is now typed out. But that's not fun enough. So let's do something with that name. Let's add something to it, like hello. So now we've added hello and the name. And let's add exclamation point at the end. There we go. And we'll run that. So again, type the name. Hello, Eric. Awesome. So now what else can we do? Well, let's add some more information. Let's ask for their age. So age gets input. What is your age? And they give us some kind of answer. And then we will add that here. So hello, Eric. And then we'll write some more. You are plus, and then we'll add our age. And then we'll add more text. Years old, period. And we want a space here as well. So let's try that. I'm running it. I get a box, ask for my name, Eric, and it asks my age. What's your age? Let's say I'm 37. Not, but let's pretend. So it says, hello, Eric, you are 37 years old. Awesome, right? So this is one way to get some input. Now let's try and build something more interesting. Let's try and build a calculator. See how that works. So in a calculator, we want to ask for a number. So we have number 1. And we'll ask the user for a number. So input, and we will say enter a digit. There we go. And then we want another number. So num2 gets input, enter a second number. And then we'll do something with those numbers. We'll add them together. So we'll say answer gets num1 plus num2. And then we will print the answer. Print answer. What happens if we run this, do you think? Well, actually, it's not going to work. And do you know why? Well, we're entering a digit up here, and it's going to be a string. And we're entering a digit here, which is going to be another string. So we need to convert these to some kind of number. So let's typecast them into a float. That looks a lot better. So let's try and run that. So it's asking me for a digit, let's say 4, and then another one, 12. The answer is 16.0. Wonderful. So that's a way to get some user input, and see you next time. Hey, welcome to the exercise. Now we're going to do a user input exercise and flex our programming muscles. So here on the slide, we have the exercise. We're going to create a distance converter, converting kilometers to miles. So we're going to take 2 inputs from the user, the first name and the distance in kilometers. Then we're going to print a greeting where we greet the user by name and we show the kilometer and mile values. And 1 mile is equal to 1.609 kilometers. And then as a hint, make sure we use the correct types for calculating and print, and then remember to capitalize the name. So let's remove this and go up here, and I'll paste this as some help. Why don't you give that a shot, and I'll be back in a second to show you one way of solving this problem. All right, I'm sure you did awesomely at this task. So let's take a look at this and what we need to do. So the first thing we need to do is take 2 inputs from user. So that's 2 inputs. Let's take the first one, the name. Let's just call that name. So name gets input, enter your name. Then as the second input, we're going to get the distance in kilometers. So we'll call that distance underscore kilometers. And that's another input. And we'll say enter distance in kilometers. And then we're going to calculate the distance in miles. So we'll create a variable out of that, distance miles, which is equal to a float. So we need to convert the number that we get in the input box, because when we create an input and capture it, it's always a string. So we could convert that in the input line when we get distance kilometers, or we can do it now. So in this case, we're doing it right here. So we'll convert to a float the distance in kilometers, and then we'll divide that by 1.609. And the next step we need to do is write a print statement where we greet the user by name. So let's do a print, and we'll use an F string. So we'll say F, and then we'll say I, and the name, and we'll capitalize that. We'll say title, and the curly brackets, exclamation point, space, open a new curly bracket for the variable that we're going to put here. So we'll use distance kilometers, close the curly bracket. The text km for kilometer is equivalent to, then we have the next variable, distance miles, close the variable, and the word miles, period. So that should work. Let's see what happens if we run it. We get an input box, enter the name, we'll say John, and we'll say 10 kilometers. So it answers, hi John, 10 kilometers is equivalent to 6.215 and a lot of decimals. So probably we might want to round that number, don't you think? So the way to round it is to go in here to distance in miles and round that number. We simply say round, parentheses, and then after the variable, put a comma, and then how many decimals we want to see. Let's say 1. And then we close the parentheses. There we go. And let's run it again. So we'll say John, and let's say 14 kilometers. Hi John, 14 kilometers is equivalent to 8.7 miles. And now we've solved that issue. Awesome. So I'll see you in the next cast. Now we'll take a look at lists. So lists are used very often in programming, and they're very similar to variables. So a variable can hold a number or a string or a Boolean or something else. And a list can hold multiple instances of these. So you might have a list of 500 names or 500 numbers or maybe even 500,000 numbers. And so they're very practical. And the way you create a list is, again, very similar to how you create a variable. I'll give you an example. Let's say I have some friends. Friends and friends get, and then we use square brackets to hold the friends. So we'll have our first friend, John, then we insert a comma, next one, Michael, Terry, Eric, and Graham. We finish with another square bracket, and we're done. So that is the list friends. And now if we print that, we see that we print the list. Now, very similar to a variable, the way we access the different parts of a list is by using an index. And it's the same way that we access content in a string. So the first one is position 0, the second one is position 1, third one is position 2, and so on. So that's how you access values in a list, very similar to values in a string. So one way you can access parts of a string is to actually print the index that you want. If I input 1, I'm going to get the Michael, and we printed Michael. If I want 2, I can say friends, square bracket, and then maybe number 4. So now it gets Michael and Graham. There's another way, similar to what we did with strings and slicing, where you can ask for different parts of the list. So let's say print friends, square bracket, 1, and again it will print Michael. We can then use negative indices like -1, which will give us the last number. We can use the slicing syntax using the colon, so we can say from number 2 to number 4, but not printing the actual number 4. So we get Terry and Eric. And again, exactly as we did with strings, if we don't have a first number, it will assume that we mean from the start of the string. So we get John, Michael, Terry, and Eric. If we don't input anything, we get the whole list. We can also get some different information about the list, like for instance how long it is. And the way you do that is by using the same command we did in strings, len. We run that, and we find out that there are 5 elements in the list. What if we want to find out at what position Eric is? Well, we can say print friends index Eric. And that tells us that Eric is at index 3. We can also count the number of occurrences of Eric. We can do that by using the count function. So those are the very basics of strings, and we'll continue with some more advanced commands in the next tutorial. See you then. So we're back with our friends list, and I've also added a cars list. So those are model numbers of cars. I'm sure you can guess the brands. And one thing I didn't mention last time is that lists can actually contain a mix of different things. They can contain a mix of strings, numbers, Booleans, and so on. You can mix them any way you want. Okay, so I thought we'd start out with some sorting. So in order to sort a list in place, which means that we're not creating a new list, we're sorting the one we have. You say friends dot sort, and then we'll print that as well so we can compare the two. So now it's going to sort it in ascending order. So as we now see, we start with the first letter and then we have sorted it in the right direction. If we want to change the order, we can say friends dot sort reverse equals true. And the capital T is important because it's indicating a true statement for the Boolean. Okay, then we'll print that. Now you've sorted that in descending order. Now there's another function called reverse, which reverses the string. So it's not a reverse sorting in descending order, it just reverses the order of the original string. So the way you use that is friends.reverse, and you get the original string reversed compared to how it was before. So those are ways to sort lists. We could, of course, do the same thing with the numbers. If we change this to cars, we see that we've sorted the list of cars. Okay, well that's great. So now let's get on to some other stuff. One thing we might want to know about a list is what the minimum, maximum, and maybe even the sum of a list are. So let's try some of those. Let's say print min of cars. So that gives us 130. So that's the lowest number in that list. If we change it to max, we'll get the highest number, which is 911. And if we wanted to sum them, we can do that. We get 2,952, completely irrelevant number. So you don't always just want to do things out of the blue. The sum wouldn't work in the friends list, and I'm not sure even what would happen if we do min on the friends. Oh, okay, it does work. So that gives you the lowest value of the list, or the first letter. So that means we should be able to do max as well. Yeah, so I learned something. I've honestly never done that before. So now let's continue with modifying lists. So get rid of this, go up here. When we're working with lists, oftentimes we want to add something to the list. So for instance, we might want to add another friend. And the way we can do that is by using either an append statement, an insert statement, or we can just specify the index where we want to input something. So we'll start with the easiest one. We just add another friend to our list. So we will say friends, append, then we input the name of the new friend, Terry G. We run that. We now say that we have an extra friend called Terry G at the end. So there are other ways we could add Terry G. We could insert him at a certain point. We would then use the insert statement, and we specify the position where we want to insert him. So 1, that inserts him at position 1. So let's take a look at our list. So as we see, Terry G is now at position 1, which is the second position in the string, or index number 1, I should say. Another way we can do this is to use the index directly to specify. So then we would just specify friends and square brackets, the position where we want him, say 2, and then we set that position to get Terry G as a value. Now as you notice, we now removed the old Terry and replaced that Terry with Terry G. So now we've not appended the list or added to it, we've actually changed one of the values. Another thing we might want to do is extend the list. I put two lists together. So we can do that by saying friends, extend, and then we specify the list we want to extend with. We run that. Now we get a long list where everything has been added together in one long list. The next thing we might want to do is completely remove things without putting something new in there. Then we can use the remove, pop, or delete functions, and those are slightly different, and I'll run through them. So first, we might want to just remove something, and the way we can remove something is to specify which one we want to remove. So let's say friends, remove, we'll specify Terry, so we remove Terry. Now you see we have a list of 4 names and Terry's gone. Instead of using remove, we can use the command pop. And pop does something slightly differently to remove. So when you remove something, you just remove it. When you use the pop function, you actually pop it into memory so that you can use it in your program. So if I want to specify pop, this will by default grab the last or remove the last name in the array. If we run it, we see that the array has now lost Graham, but Graham has actually been popped, so we can use that name. You can also specify what you want to pop. So if you want to pop number 2, you can do that. Now I've popped the second index, that was Terry, or I could pop -1, so this is the same kind of naming as we use when we're slicing strings or accessing indexes. So pop is really useful. Those are some ways to remove individual parts of the list. We can also remove the whole list. We can start by just clearing the list. The way you do that is by specifying friends, clear. We now have an empty list. But if we want to remove it completely, we would say delete del friends. Now, as you see, there is nothing to print at all anymore. It's just gone, so we get an error. We can do the same thing if we just want to delete parts of the friends. So if we use del friends and we specify 2, we still have the list, but we now remove index 2, i.e. the third object in the list. So del is a bit more powerful, so be careful with using that. And lastly, let's get on to copying lists. I'll show 3 different ways that you can copy lists. So the first one, let's say we have a new friends list. New friends equals friends, and the first way we can specify is to say square brackets and colon. That creates a new list, and we'll print this one as well. So we'll print new friends. We've now created a copy of that. Another way you can specify this is to say new friends copy. Remove the square bracket part. This will do the same thing. It will copy and give you a new list. And the third way you can copy a list is to say list friends. Great. I hope that wasn't too confusing and that you now know how to manipulate lists. I'll talk to you next time. Welcome to this exercise on lists. So in this exercise, we have a lemonade business, and we're going to keep track of our best and worst days and our combined total for those 2 days. So in the back here, we have 3 lists: the sales of week 1, the sales of week 2, and then a list called sales, which is just empty. So here's the exercise. We sell lemonade over 2 weeks. The lists show us the number of lemonades sold per week. Profit for each lemonade sold is $1.50. We're going to add another day of sales to week 2 by capturing a number as an input. Then we're going to combine the 2 lists into a list called sales. Calculate and print how much we've earned on the best day, on the worst day, and then separately and in total. So a total of 3 prints. All right, so give that a shot. I'll reduce the slide over here and you can look at it anytime you want while you're working. So have a crack at that and I'll be back shortly. All right, how did that go? I'm sure it went awesomely. Okay, so let's look at what we need to do. The first thing we need to do is get that new day of input. So let's call that data new day, and that gets input. And let's ask the user for some input. We'll say enter number lemonades for new day. So here we'll capture some number in this new day variable. So then let's append that to the week 2 sales. So that's sales week 2. Append. And when we capture the new day from an input, it comes in as a string. Remember, all input is captured as strings. So we need to convert this into a number. So let's convert it into an integer. We could convert it into a float as well, but since they're going to be whole numbers, it doesn't make much sense. So let's just make it an integer. There we go. We've made new day into an integer and we've appended it to sales. That's great. So the next thing we're going to do now is combine the two lists. And we're going to do that in two different ways, and I'll show you first this one. We're going to use the extend method first. So sales is that empty list we have. So we're going to extend that with sales of week 1 first. Now it would be nice if we could extend it immediately with week 2, but for some reason that doesn't work, and that's a bit annoying. So we have to do the same thing again. So we'll copy this because we're lazy and don't want to make mistakes. And all we have to change is week 2. So now we've extended it twice. So that's one way of doing it, by using the extend method. Another way to do it is to simply add the lists. So sales gets sales week 1 plus sales week 2. Now I see an obvious benefit to this. We could add sales week 3, 4, 5, 6, 7, 8, 9, and 10. And if we did that with the extend method, we would have 10 rows. There are some other methods in Python, of course, but we haven't talked about those, so I'm not going to cheat and use those here. So I actually kind of prefer this one, but let's comment that out for now, and I'll show you later that it works. All right, so what's the next step? Now we're going to sort that combined list, the sales list. And the reason we want to sort it, so sales sort, is so that the first number will be the lowest number, and we're going to grab that for the worst day. And then the last number in the list is going to be the highest number, so that's the best day. So we're going to grab that as well. So that's the next step. So we're going to grab the numbers for first day prof or profit, and that gets sales, and then we're going to slice. So we'll get the first position, which is 0, right? We're going to multiply that by 1.5, which is $1.50 per lemonade sold. Okay, and then we're going to copy this and change that to best. And in this case, we're going to use the last position in the list. So that's -1, remember? And then we're going to do some prints. So we'll print an F string, and we'll say worst day profit, colon, add a $sign. So the worst day prof, close that curly bracket, and we'll copy this print statement. And then we'll get the best day. Change that to best day. Then for our last print, which is our combined days, so the best day and the worst day, so we'll call that combined profit. So that's the worst day profit plus best day prof. There we go. So this should be our code. Let's give it a shot and run it and see what happens. So we get a text box. I'm going to enter 10 lemonades for that extra day. And here's our result. Worst day profit, best day profit, and combined profit. So now I'm going to show you this thing that we tried up here. So I'm going to uncomment that and comment these two instead. So they are now no longer active. So let's try that code. Again, we'll enter 10 and we get the same result. So that's awesome. That's two different ways of using it. I actually like this plus version better because you can extend with more. So now I'm going to show you one more thing. So here, when we created these worst day and best day with the sales and the slicing of the list, we can actually do that in a different way. Instead of using the slicing, we can say min. So that's the minimum value of sales, and we don't need the slicing then. And then we can say max for this, which is the maximum value. And if we do that, we of course don't need to sort the list, which is useful. So let's try and run that. Again, I get a pop-up box, enter 10, and we get the same result again. So that's fantastic, right? So now we've solved all our problems for our lemonade business, and we can just continue to make money. And you are doing so well. And I'll see you in the next tutorial. Hey, now we're going to take a look at splitting and joining. So sometimes you want to split apart strings that you have, and sometimes you want to take lists or tuples or something else and join them into a string according to your own preferences. Let's start with some data to work with. So there are three variables. We have a string, we have a second string separated by commas, and then we have a list of friends. So we are going to start with the top one, message. What could we do to break this string apart? Well, one thing we could do is turn it into a list by using the list command and then calling message. And that breaks it apart completely. That's not at all what we wanted. So luckily, there's a function called split. And it's actually a method on the string object. So if we run that, it splits our string apart into a list, and it's separated by white spaces. Now this could be written in a different way. You say split, and then you say on what type of character it should split. So let's run that. That gives us exactly the same result. But these functions are actually different, and you'll see that if I introduce some spaces here. So we'll introduce extra spaces. We run it again, you'll see that the top one doesn't care that we have multiple spaces or white spaces involved, but the bottom one does. It actually shows those as empty strings. That's not really what we wanted. So that's something you need to keep in mind when you're using these splitting functions. So what are we actually splitting into? Well, if we copy this and ask what the type is and run it, we see that when we split, we create a list. So we're splitting from a string and we are creating a list. So depending on what your string looks like, you can just input whatever it is that the splitting character should be into this split. So in the case of the second one, we want to split on the comma in the CSV file. So let's try that. CSV split on comma, and we'll get rid of this and this and run that. Now we've split the comma separated file into a list with the names of our friends. So with that information, I think you can split most any string that you come across, as long as it only needs to be split on one character. Okay, so now we'll move on to our friends list, and we are going to join that into a string. So again, let's try something similar to what we did first with the message. Let's try and turn it into a string. We'll say string, friends list. We run that. Now that looks like a list, doesn't it? But it's actually a string, and it's not really what we wanted. We wanted to turn this into a string that looks like a string, that doesn't have the square brackets at the end. So let's try something different. We'll now use the join command, which looks like this. We specify what the joining character is going to be. Let's use a hyphen, period, then we type join, and then the object is the friends list. We run that. Now we get Eric, John, Michael, Terry, and Graham separated by a hyphen. That's excellent. And that is indeed a string. If we wanted to join multiple versions of this and concatenate two strings, we could do that as well. So we could join it twice. This could, of course, be another list. It doesn't have to be this one. We do that, we get it twice. Okay. Now if we join it on nothing, an empty string, it just joins everything into one long string. Now, given that we know that when we split, we turn something into a list, and when we join, we turn it into a string, that means that if we start out with a string, we could create a list and then go back to a string. Now, why would we want to do that? Well, one example would be if we want to strip out all of the spaces from a string, like the one we have above, the message. So how could we do that? Well, let's try this. We can run print. Now, the first thing we might want to do is split our message on white space. So that turns it into a list. And after we've done that, we want to join it, but we join it with an empty string, parentheses around that, and closing the parentheses. Now if we run this, it should strip out all the spaces. Let's see how it works. Welcome to Python 101, split and join without spaces. Now there's a more convenient way to do this that doesn't run through join and split, and that's to do print, and this time we will just do message replace, and we replace all the spaces with the empty strings. This should basically do the same thing, and it does. And that's an introduction to using splits and joins. I'll see you next time. Okay, welcome to the exercise. So we have a CSV file, or rather we have a CSV variable, which is filled with names that are separated by commas, but unfortunately also by a colon and a semicolon. So somebody obviously messed up. And our job is to separate it anyway. And we need to turn the CSV variable with the names into a list where we have one name per slot. And then at the end, we're going to print that friends list to prove that we've finished this. So that's your task. Give that a try, and I'll talk to you shortly and show you some ways to do this. Okay, awesome. You're back. I hope that worked. And now I'll show you two different ways that you could solve this. And I'm going to do sort of a roundabout way to walk through it so it's clear. So what we're going to try and do is use this join and split function, which we used before, to do this. So we'll start with the CSV, and we'll start using print statements to make sure that we're doing things correctly. So the first thing we'll try is see what happens if we split on just comma. There we go, splitting on comma. So what does that give us? Eric, John, Michael, Terry, Graham, Terry G, and Brian, which are not looking too great. So we didn't manage to split that properly. So we'll have to keep working on this. So let's start with one of the ones that's not the final splits. Let's start with the semicolon and split on that. And then after we've done that, let's join on the comma again. So join, parentheses. We need to close that parentheses as well. There we go. What does it look like now? We managed to separate Terry G and Brian, but we still have that colon that we don't want. So let's keep going. Let's copy this. And let's do another split. We'll go in here and split. This time we'll split on the colon. So what's that going to give us? Now that's giving us a list, and we have managed to split them apart properly. And now we add another, we'll copy this again. We'll add another join at the beginning. So we have join on comma again, and then we need parentheses, and we need a parentheses at the end as well. So if we run that, it actually looks good. We now have a string that's separated by commas. So all we have to do now is split that. So we'll copy this again. And we need to do one more split at the end. We'll say split on the comma that we wanted to do from the beginning. Need to close up all the parentheses properly. So we've got one there. Try that. Now we managed to turn them into a list. So let's get rid of all the ones except the last one. There we go. Run it again. So there's our list. Now we take that list and we put it inside here to create our friends list. And now we're printing the friends list, so we can get rid of this. There we go, we've printed it. All right, awesome. So we've solved that problem. There's another way you could solve this. You could use the replace function that we used before. So we could say print, but this is using replace. So CSV, replace. Now we want to replace the semicolons with commas. And then when we've done that, we want to do a second replace, where we replace all the colons also with commas. So that's going to keep everything still as a string, and then when we're done doing that, we need to split everything. So then at the end, we're going to split everything using a comma. So is that going to work? Let's find out. So replace has Eric, John, Michael, Terry, Graham, Terry G, and Brian. So that worked as well. Now, probably the main reason to run this exercise is to show you how cumbersome it is to use the split and join and even the replace functions to do these things. Now, there are much better tools for this in Python, especially if you start using regular expressions, and we'll get into that in a future tutorial. One of the reasons to do this is to get you psyched to use it, because it's super useful and a lot less work than this is. So I hope you look forward to that. I'll see you next time. Okay, let's talk about tuples. So tuples are lists that you can't change. So we looked at lists before, and we've done some things with them. We have a friends list up here, and a tuple is actually a list, and you can't change it. And they're also slightly faster, probably because you can't change them. Remove some complexity that makes the computer handle them faster. So I'll show you an example of what a tuple can look like. I'll use the same list. So we'll call this friends tuple. We have the same people in it. And as you see, the only difference is that instead of square brackets, I'm using regular parentheses to enclose it. And that makes it a tuple. So let's see what we can do with it. We'll paste that in there, and we'll change the name to friends tuple. And if we print those, we get the same result. They both show the same thing. And we can access the elements in the same way as well. So if I want to access element 2, I can do that here. If we run it, we get the same result. We can also slice, both as we've done previously, 2 to 4, 4. So they do exactly the same thing. The main difference is that the tuples you can't change. They're what's called immutable. So when you create it the first time, that's the tuple that you have. If you want to change it, you'll have to create a new tuple and save the old one into it. Also, because of their, I guess, less complexity, or them being less complex, they're also slightly faster to work with. So iterations or searches are faster in tuples than they are in regular lists. Now, getting data about the tuples, you can use the same functions that we use for lists, but you can't use any of the append or remove or pop or any of these functions. So when do you want to use a tuple instead of a list? Well, if you have data that you don't want to change during your program running and want to make sure that it doesn't change, a tuple might be a good way to go. Then there are also some secret magic ways to make tuples behave more like lists, which you'll learn when you become more advanced, but I'm not going to talk about that here, so you'll have to look that up on your own for now. I'll speak to you soon. So because lists and tuples aren't enough, somebody figured out that we have more bracket characters on the keyboard, and we should really use all three of them. So curly brackets, we need to do something with. So somebody figured out that we could make up sets. And sets use curly brackets, just like tuples use parentheses and lists use square brackets. Sets use curly brackets. And the main difference between a list and a set is that a set is unordered and it also removes any duplicates that are inside it. So only one of each thing can exist in a set. Sets are also a lot faster at finding members inside the set than a list is. Can be up to 100 times faster. And in programming, speed is a reason all on its own to do things. So let's take a look at what it looks like if we print this out. So as you noticed, I've added an extra Eric at the end here, just to show you that it's going to be removed when we do the printout. So we print, and as you see, that last Eric is gone. But we don't see any sight of the fact that it's an unordered list because it's printing in the same order every time. I'm not sure why that is. In some Python interpreters, it actually shifts the order around randomly. And the fact that it is unordered is probably one of the reasons why it's a lot faster. So what can we do with sets? Well, we can do basically the same things that we can do with lists, but sets are faster for some things. I'll show you some examples of when they are faster. So we'll remove this. Now we have a second set, my friends set, and then we have a command at the bottom which says print friends set dot intersection my friends underscore set. So what this is going to do, it's going to print the members who are in both friends set and my friends set. So in the top one it's John, Michael, Terry, Eric, Graham, and Eric. The bottom one is Reg, Loretta, Colin, Eric, and Graham. So which ones are in both? Let's find out. So Eric and Graham are the ones that exist in both. We can also find the ones that are not in both. And then we say difference. We run that. We find that John, Michael, and Terry are the ones that are different. These are the ones in the friends set that don't exist in the my friends set. That's how it's measured. Another thing you can do is take the two and put them together by using the union command. So this now gives me a set with all of the names in both of the sets with no duplicates. One last thing we can look at is the behavior of lists, tuples, and sets when we're creating empty ones. So take a look at this. So when you're creating empty lists, if you create an empty list, you only need 2 square brackets. That will give you an empty list called empty list. You can also use the list command. With an empty tuple, you can create an empty tuple by using 2 parentheses, or you can use the command tuple. With an empty set, if you try to use 2 curly brackets, you'll actually end up with a dictionary, which is not what you want. So you cannot create a set by just specifying 2 curly brackets. An empty set should always be specified by the command set, but you can of course create a set that has members or content with just using the curly brackets. You don't need the set command then. And that's about everything I know about sets. That was pretty quick. I'll talk to you next time. All right, let's do an exercise on sets. And part of this exercise is to help you relate regular words to things that we do in set theory and programming. So what we'll do is I'll read out each one of the 6 questions. You give it a shot one by one, and then I'll show you a solution to them one by one. Sound good? All right, let's get cracking. So how about the first one? Check if Eric and John exist in the set friends. So first, maybe check if just Eric exists, and then check if both Eric and John exist. Give that a shot. Okay, so what we're going to be performing is a membership test. We will ask if Eric is in set friends. So is he? Turns out he is. But if we want to check if both Eric and John are in friends, well, in that case, we need to do the same thing again. So we'll say John in friends. And we're asking both Eric and John are in friends. Let's see if they are. They are. That's awesome. So the next one, combine or add the 2 sets. How would you do that? Give that a shot. All right, in this case, we are going to be using a union. Print friends union, and then union with what? Well, with my friends. There's actually an alternate way to write this. It's shorter, and we'll start by copying that, pasting it, move one of the parentheses, move that, and instead we'll use the pipe character. That means union. Let's run those and see if we get the same result. And we do. What about the next one? Number 3. Find names that are in both sets. So did you try that? I hope you did. So in this case, we're going to be using the intersection. And for intersection, use the and sign. This is going to give us all the names that exist in both of the sets. And that's just John and Graham. Next one, number 4. Find names that are only in friends. How would we do that? Well, we'd use the difference. The difference, easy to remember, uses a minus sign as the shorthand. So what are we actually going to get now? Well, think of it a bit like subtracting the two sets. So we'll run it first. Look at what we get. We get Michael, Terry, and Eric. Those exist only in the first set. So what we basically do is we subtract the second set, my friends, from friends, but we can only subtract the items that actually exist in friends. So it doesn't help much to subtract Colin because Colin isn't part of friends. But we can subtract John because John is in friends, and that's why we get the other ones left over. So it's sort of a weird kind of subtraction. What about if we turn it around and say, my friends, say friends here. We're going to be subtracting friends from my friends. What would you expect the result to be? That's right, a different one. Now we have Reg, Loretta, and Colin, which exist only in my friends. So just to prove that it works, we'll change this as well. So there we go. All right, number 5. Show only the names that only appear in one of the lists. How do we go about doing that? Well, luckily there's a function for it. Symmetric difference. Now, you're wondering, how do we do symmetric difference? And it's the roof character. So what that's going to do is show us all of the different items or members that exist in just one of the sets. So Reg, Loretta, Colin, Michael, Terry, and Eric. These are the ones that don't exist in both of the sets. Alrighty then, as the last exercise, create a new cars list without any duplicates. How do we go about doing that? Well, we actually sort of did it when we did the union because we were using sets. And we're using the function in sets that they don't contain duplicates. First, we'll create a variable, cars, no duplicates. And we'll set that to be the set of cars. Because cars is a list, so it can contain duplicates. But a set can't. Then we print, there's no duplicates. And we get a set without duplicates because we turned it into a set. If we want it back into a list, turn it back into a list. And voila, we have a list with no duplicates. Awesome. So I hope you enjoyed that. I'll talk to you next time. So comments are text in the code that Python just ignores. So it's mainly for communication between humans. The 3 main reasons to write comments. Number 1, writing notes to other humans about the code so that they can keep track of what it does, how you were thinking when you built it, maybe even a to-do list to yourself or to others on what needs to be done in the code, or some other interesting comment. Number 2 is mainly for debugging or testing, where you can disable lines of code to see what's running and what's not. And then number 3, auto-generation of documentation about the code. And we're not going to talk about that here. And seriously, if that's the kind of code you need to write, you're probably in the wrong tutorial. So let's get into what comments actually look like. So underneath the print statement here, we actually have a comment. And it starts with a hashtag or a hash, or what used to be called a pound sign. And anything we write after that hash is ignored by Python. So now you see it lighting up. As soon as I put the hash there, it goes gray. So basically you can see the hash as a message to Python saying, no, bad dog, don't touch this code ever. And that's basically what it is. So this is a way for us to hide messages from the computer. So you can do this, and if you want to do multi-line, there is really only one way. You have to add another hash to the next line and keep writing more comments. There is a way around this, which isn't sanctioned in any way, and it's not really good practice. So you can do this, then you can write multiple lines of comments. So for instance, which while being true is not really useful as a comment. As you see, if I run the code, it's just going to run this print statement. And it's not going to show us the comments, and it's also not going to show us the string that I typed. And the reason it's not showing the string is because it's not allocated anywhere. So immediately when Python runs, it just deletes that string. So that's why it's not being shown. So it's not really a comment. It's actually a string, but it's not being allocated anywhere. So probably not a good idea. Maybe Python will have multi-line comments in the future. So here's a list, fruits. And above it, I've written fruits holds the fruits input by the user as strings. So that tells whoever is working on this code what it actually does. What about troubleshooting code or experimenting, which I mentioned? How does that work? Well, let's take a look. Let's say we have this code in front of us. and it doesn't work. We don't know why, so we read the comments. What is this? Entry form for ministry applications. To do. Fix it. It doesn't work. Okay, great. So we have a name. We have then a name being assigned by an input, and then we have a print statement, and apparently nothing works. So let's try by commenting out a line of code or two. So when I do this, as you see, it goes gray. That means Python's going to skip over it. And let's run it again. Now it runs. So I know that the lines that I have uncommented now are okay. So let's uncomment this one as well. It still runs. So it looks like the row that I have here is the culprit. Maybe there's something wrong with this. Let's take a look at it. It looks like somebody forgot to make it into a string. Let's see. I get a console that you don't see, and naturally, Loretta needs a job. And it says, thank you, Loretta, for applying to the Ministry of Silly Walks. And now we'll do this. Fixed. Or we'll just delete the row because we've fixed it. There we go. Try to comment your code so that other people can understand it better, and use comments for debugging and testing. Good luck, and I'll talk to you soon. Okay, time to talk about functions. And functions, they're a way to bundle together code you often use to make it easier to reuse later. So if you often use or copy the same lines of code and use them again and again, maybe that piece of code or that snippet might be a good candidate to make a function out of. Another good thing with functions is that it allows you to split up your code so that it's easier to understand and read, both for yourself and for others. And you'll find that yourself is going to be important as you move on and write more code, because you're going to find some old code that you wrote a long time ago that you just don't understand without having useful names, which is another thing. You should always use names that you understand. That makes it easier for you and for the rest of the world to read your code, and of course to use your code. Another rule that you should remember about functions is this. Always declare functions before you're going to use them. Okay, so always declare the function above where you're using it. Okay, great. So now let's get into writing some code and creating some functions. Here we have a print statement, which is not super useful. So we're going to turn this into a greeting message. So what we're going to do is move that down one row, and we're going to start with def, which is a keyword, which means define. And that's what you use every time you want to define a function. We're going to define a function called greeting. This is how you define a function. You type the name, and then you have two parentheses. You finish with a colon. Now, everything underneath that define greeting is going to be part of that function, as long as it's indented. So let's indent the print statement. There we go. Now it's part of the function. So this print statement will change, and we'll say, hello, friend. That's a personalized message anybody could use in an e-commerce message, right? Awesome. So then we're going to run it. So what do you think is going to happen? Let's try. Nothing. And why is that? Well, in order to use a function, you have to call the function. So let's call the function. How do you do that? Well, you write the name of the function and you finish with the parentheses, and that's all you need to do. So let's try that. Look at that. It prints out the message, very personalized, hello friend. That makes any user on your site very happy. Great, so we're going to make that user a bit more happy now by trying to send a personalized message to them. So the first thing we're going to do is specify in our function something called a parameter. And a parameter is some kind of variable that we're going to use inside our function. So let's do that. So we'll say name. And then we're going to use name down here. So we're going to extend and concatenate the string. We're going to say hello plus name plus an exclamation mark. Now we also have to specify what's called an argument, which is what we're going to send from the call of the function. And let's say that we want to say hi to Brian. Okay, let's try and run this. Look at that. Hello, Brian. Now it's much more personalized. He's going to be so happy, right? But we want to be even more personalized. So we want to personalize this more for Brian. We want to add something he's going to appreciate, like maybe his age. So let's put a comma here and put another parameter in there. And we're going to call that age. We're going to use that down in our print statement, the age. So we'll say, hello, Brian. And then we're going to say, you are age. And again, the exclamation mark. So there we go. So now it's going to say, hello, Brian, you are, and whatever the age is going to be. We also need to specify the age in our call. So that needs to be sent along as an argument. Let's do that. Comma, and then another argument. So we'll say that Brian is 32. So let's run that. Hello, Brian, you're 32. And maybe we should have put a space there to make it look better. There we go. So now we've personalized this, and you're starting to notice that this print statement is getting slightly unwieldy, right? And we talked about formatting strings before, and I'm now going to use that just to show you how convenient they are. So print, and we're going to say hello, and then we want to say the name, right? And the way we say the name is using curly brackets. Name, comma, space, you are age, exclamation point. Now, do you feel that that message is shorter and snappier and easier to read than the one above? I sure do. So let's use both of those and see what the result is. Well, that wasn't great. Now, what mistake did I make now? Ah, yes. You have to specify an F before for the format. Sorry about that. There we go. Now we have the same message twice. And the second one is a lot easier to write, as long as you remember the F, which I omitted. Okay, so let's keep going. Now, sometimes we might not know the age of our subject or the person we're working with. So we might have it on file for some people. So maybe sometimes we need a default value. So let's try a default value. And the way you set a default value is set one of the parameters equal to something. So in this case, we'll set it equal to default, let's say 28. So if we don't send a number for age, it's going to choose 28. So that makes our thing a little bit more flexible. So let's try that. Let's do another greeting. So greeting, Judith, and we don't send an age for Judith. And let's run this and see what happens. Look at that. So we have two greetings, and the one for Judith says 28, our default value when we didn't have one. So that's how you add a default value. Now, another thing we might want to do is actually take the value to use as name from an input box from the user. So let's try that. Input. Enter your name, and that will be the variable name. Then we'll use this inside here. So now we will get an input from the user, use that in the greeting, and send it as an argument to our function greeting. So let's try that. I get a box that you don't see, which I'm going to fill out with Peter. Now it says, hello, Peter, you are 32, and Judith, she's still 28. All right, great. So now what I'd like to do is change the 32 into a real number, not a string. So I want that to change. And I want to change it up here as well. I don't want it to be a string anymore. And now you'll notice something cool very soon. So let's run this again. So I run it. We'll say Peter again. Now we get an error. And the reason we get an error here is because of this line right here. The age is expecting a string because it's concatenating a string, but we're not sending one. We've turned the age into an integer. So we need to convert that integer into a string. So why did I say that was cool? Let's run it again and you'll see why. So Peter. Now we're getting the answers, but we didn't convert the string on the age down here. We didn't do the string conversion. Why is that? Well, because it works anyway. Isn't that cool? So you don't have to do the string conversion here. We can just put it together in this way. Now with that, hopefully I've given you some indication that using formatted strings is a lot easier, both on your eyes and on your work, and making less mistakes. And also you don't have to convert integers into strings and floats and so on. So I hope to see you in the exercise soon. Okay, welcome to this exercise on functions. So what we're going to do is modify the above function. And the instructions are below, starting with 1. Add a new print statement on a new line, which says, we hear you like the color XXX, which is a string. Then number 2, we're going to extend the function with another input parameter called color that defaults to red. Capture the color is going to be done via an input box as a variable called color. Change the URXX text to say you will be XX plus 1 years old next birthday. So we're going to add 1 to the age. Then we're going to capitalize the first letter of the name, make sure the rest are small caps, and the favorite color should be in lowercase. So there's the exercise. Give that a shot, and I'll be back with one possible solution in a jiffy. Just remember that you have 2 print lines, one which is not a formatted string, and one which is. You can work on both of them for practice. All right, I'll see you soon. Okay, are you done? Awesome. All right, let's get cracking at this. So the first thing we want to do is add a new print statement on a new line. All right, great. So let's do that. We'll say print. And what's it going to say? Formatted string. We here. We like the color. And then we're going to input some form of variable here, I guess. So let's open it up and put something in there when we know what we're going to call it. And exclamation point. There we go. So what else? Extend the function with another input parameter, color, that defaults to red. Well, input parameters go up here. So we're going to take color, and it's going to default to red. There we go. Now we've set another parameter, and it defaults to red. Now we're going to capture the color via an input box as variable color. Okay. So we'll put that down here. Color gets input favorite color. There we go. And then we're going to change the XURXX text to say you will be. Okay. Say, start here. You will be. And then string. And we're going to add 1. So whatever the age string is, we're going to add 1 to it. So we'll say age plus 1. And then we also want next birthday. So we'll say space, next birthday. And then we'll do the same here. Low name, you are age plus 1. Not you are, you will be. Age plus 1, next, birthday. And then we need to handle our variable here. So color should be color, right? And then we want it in lowercase. So we'll call the lower. Go. Now we also need to change the call to the function. Greeting, name, and then we have an int, which is our age. We have the color. So is that about done? Right, we need to capitalize the first letter of the name. So our name is here. So name capitalize, and capitalize this one as well. This should be done. Maybe we should improve comments. Age next year. So is that about done, do you think? Let's give it a whirl and see if we can fix something. Get a pop-up box, enter your name, let's go with John. Enter your age, let's go with 22. And favorite color, hot pink. So what do we get? Hello, John, you'll be 23 next birthday. And the other one seems right too. We hear you like the color hot pink. Awesome. So that's one way to solve this. Of course, you could have solved it in many different ways. And the main point with all these exercises is just to practice, make an effort, and try to do the best you can. Hopefully you can learn something from the solution and from your own attempts. All right, I'll see you next time. All right, let's talk about name notation and functions. But first, I want to mention that it's really important to comment your code. The more you comment your code, the easier it is for you and for other people to understand what the code does and what it's supposed to do. So let's look at our old code. So we had this code before, where we had our greeting, where we had the parameters name, age, and color, and then we printed out a message based on that. And we called our function with this greeting call down here. And that works. Run it, and as you see, we're printing the Hello Brian row twice, and I'm now going to remove this top one, this string concatenation. I think we've agreed that that is more tedious to work with than these formatted strings, which are much more pretty. And as you see, I've commented my code right here. Greets user with name from input box and age. If available, default age is used. If unavailable, it should say. There we go. If unavailable, default age is used. Expertly commented. So as we said before, in regular function parameters, we learned that to call the function with arguments in the same order as they're listed, or it won't work. And that is not entirely true. Actually, it's a bit like asking if you can breathe underwater. Well, no, you can't, but there's this thing called scuba. Same thing here, kind of. You can get around this positional argument thing by using something called name notation. That's basically putting names on your arguments down here so that they correspond to the names up here so that the function understands what goes where. That way you can pass them in any order you want, which is useful. So I'll do my best to demonstrate how to do this. And also you should know that this has the added benefit of increasing readability and clarity of your code. Just like commenting, that's always good, right? So let's take a look. So we've run this. Let's run it again. Now we only have one row. So if we throw these things around, so if I put 27 here at the front instead, and remove the other 27, what do you think is going to happen? Well, most likely, it's gonna fail. Oh, but if we name the arguments, so age, name, and color, magically it works. So by inputting the names of the different parameters down here as arguments, they match up regardless of the order we put them in. And that's really useful. And in this case, it was kind of easy to understand what was what, but you'll run into places where it's not as easy to see what's going on. So let's take an example. So here's a function called profile. Now we obviously don't have the profile here. This is just an example to show you. And we have 1995, 83.5, 192, and blue. Now you might be able to guess what that is, but we could be wrong. It's not that readable. But if we said year of birth, and then weight, and then height, and eye color, it's a lot more readable, and that would make it easier to understand. So with that, I think we've discussed some of the most important things about name notation for functions. So I'll speak to you next time. So, what are return statements? Well, Python functions are collections of code that perform a specific function. We've gone through that before. Most of the time, functions just perform that task and then they're kind of done. But sometimes we want the function to give us some kind of data back or maybe a value back. That's what a return statement is. Okay, so what we're going to do now is write some code and create a function and make it return some data. So we're going to examine something called value added tax. For those of you not familiar with the concept of value added tax, it's basically a sales tax, but it's used in other parts of the world. So there we have our value added tax, and we are going to take some input into that. We'll set an amount, indent. So now we're going to write the function. So let's say tax equals amount multiplied by 0.25. And then we'll go down here and run the function. So value added tax. And we'll input 100. And then we'll print that value and see what we get. We get none. So what's none? Well, it turns out if you don't have a return value, which we don't at the moment in the function, all functions that you call return an empty object, something called null in some other programming languages. So it just returns empty. So to get a value back, we need to modify the function. So let's do that. We'll go up here and write return. And what are we going to return? Let's return the tax. Okay, let's run it again and see what we get. 25.0. So if you buy something for 100, you have to pay 25 in tax. And that's on top of the 100, just like a sales tax. So let's calculate some other numbers. Let's calculate total amount. Equals amount times 1.25. And let's modify what we output as well. So let's say price, and let's set that equal to the return value. And instead of printing the value added tax, let's print the result, the price. And that again, we get the same result. So now let's look at some interesting things. What are we actually getting back? So let's start by adding something to the print statement. Let's check the type of what we're getting back. Let's also print the type of price. Run that. So that gives us back a float. That's to be expected, right? But what if we send more values back from the function? Let's try that. So let's send back amount, which is the value we took in, the tax, and the total amount. Now let's see what we get back. Now we get back a tuple. What if we make some changes to this? What if we put square brackets around it? Then what are we going to get back? Then we get back a list. Can we then print a part of the list? Let's find out. Let's see if we can print element 1. So that's the tax. Yep, we could do that. Okay, so what if we change it to something else? Let's change it and see if we can get a set out of here. So we change that to curly brackets, this to curly brackets. We won't actually access the individual cells because that doesn't work on a set because we don't know which one is which because it's unordered, remember? So now we get a set back. Could we change it to a string? Let's do a formatted string using curly brackets around the variables. Will that work? Yes, it will, and we get back a string. Great, so we were able to get both a float back, or if we had multiple values, we could get back either a set, or a tuple, or a list, or a string. That's interesting. I'll see you next time. In this tutorial, we're going to talk about comparisons and a little bit about the properties of Booleans. So let's start by checking some different operators. So the first operators we see here on top are the assignment operators. Those are the single equal signs. They assign a value to a variable. When you want to compare something, you can write A, two equal signs, B. Here we're asking if A is equal to B, and the answer is false because it's not. 7 is not equal to 3. If we want to check if something is not equal, we use the exclamation point. And that goes for most programming languages. The exclamation point almost always means not. So this means A not equal to B. And that evaluates to true. Next, we might want to check if something is greater than or less than. So greater than, yes, 7 is greater than 3. Less than, no, 7 is not less than 3, so the answer is false. If we say less than or equal to, we use an equal sign. So this means A less than or equal to B. That is false because it's bigger than B. And if we change the sign to greater than, it still evaluates to true. Another interesting operator is the in operator, which denotes membership. So for instance, if we have something that's an iterable, like a list or a string or something else, we can ask O in John. This asks the question if the letter O appears in the string John, and that evaluates to true. The opposite of it is the not in, so not in. That asks if the letter O is not found in the string John, and that is false because it is found in the string John. The next operator gets a little bit more tricky. It's called the identity, and it checks if two values are identical. So now we'll say A, 3, 7, 42. We will set B equal to A. Then we'll print A equals B. That evaluates to true. Now let's ask if A is B. Are they identical? Are they the same thing? And that evaluates also to true. What this is referring to is if they're occupying the same memory space in the computer. So if they are identical objects. So we can check that with the ID statement. So we can say ID of A and ID of B. So we see that the memory is 2 in both cases. Now if we instead actually allocate a list that's identical to B, we'll see what the result is. 3, 7, 42. We evaluate that, they are equal to each other, so they are the same in value, but they are not the same in memory, so that's why A is B evaluates to false. And the IDs are also not identical, so that's why we see 2 different numbers there. Now I'll paste in some comparison operators for us to use as reference. We'll run those, and you can take a look on your own. Now we'll take a look at some Boolean properties that will help us later on. So we'll get rid of these. First we'll check what happens when we make an int out of a Boolean. So we print int. That evaluates to 1. We do the same with false. We'll see that it evaluates to 0. That has some interesting effects we'll look at a little bit later. Now if we instead convert some values into Booleans, so we'll use the keyword bool. We'll start by converting some strings. So the word parrot evaluates to true. And a string with a space evaluates to true. The empty string evaluates to false. If we look at numbers, if we evaluate the number 42, it's true. 1, also true. And 0 is false. So what we see is that empty objects, or zeros, evaluate to false, and everything else seems to evaluate to true. And that's actually what happens. Let's take a look at a list. So if we have a list with 2 objects, it evaluates to true. But the empty list evaluates to false. What we find is that all trivial values evaluate to 0, and all values that are non-trivial evaluate to 1. Something else that's interesting is that Boolean values can actually be converted to 1 and 0. So if we take the number 42 plus true, we get 43. If we take the number 42 plus false, we get 42 because it adds 0, and Python does that conversion automatically. So that's a run through of some different comparison operators, and you'll get to use those as we start doing conditionals soon. I'll see you soon. Now we're going to talk about conditionals, and specifically we're going to start with if statements. So if statements are a way for our programs to make decisions. They can run different code depending on different circumstances, so it sort of makes the programs a little bit more intelligent. An example could be a website that checks if you're already logged in to run a certain function, and if you aren't, it asks you to log in. If you are, it just lets you access the function. That's an example of a conditional. Or in real life, maybe if you hold your breath underwater, when you run out of air, you come up to the surface. So the conditional might be, if I can't hold my breath anymore equals true, then stop holding breath and come up, just not in that order. So if an if statement is true, I run this code, and if it isn't, then I run some other code, or maybe just stop the program altogether. So let's create an example of a personal butler helping you figure out how to have a great day. So let's start with some kind of Boolean that tells us what the weather is like today. So let's see, is it raining today? Is raining? We'll set that to true. Then our butler will greet us with a message. So he'll say, good morning. Then we create our conditional. Move that. If is raining, colon. Then we indent, and this is the code that will get run. Print. Bring umbrella. So let's run that. So we get good morning, bring umbrella. What about if it's false, if it's not raining? Then we just get good morning. Maybe we'd like some kind of other message. So let's go down and create an else. So this means in all cases when it is not raining, we say something else. Print. Umbrella is optional. Let's run that. Good morning, umbrella is optional. Great. Maybe we'll add some more features to this. So maybe he also checks if it's cold outside. So let's put in another variable called isCold. We'll set that to true to start. We'll set this back to true. So what do we want to do? Well, now I'm going to introduce the or statement, which we'll add here. If is raining or is cold. So now, if it's either raining or cold is true, or both are true, this is going to be true, this whole statement. So then we'll say, bring umbrella. So now we'll say, bring umbrella, or jacket, or both. So let's run it. Good morning, bring umbrella, or jacket, or both, because both are true. So let's try and set one of these to false. It still executes, but if we set both of them to false, we get umbrella is optional. What if we use another logical operator called and? Let's try that. So now, this top one, if is raining and is cold, will only be true if it's both raining and cold. So right now, it's not. So let's change both to true. And if it is, we need to bring umbrella and jacket. Good morning, bring umbrella and jacket. But then we have some instances when it's either raining or cold, but not both. And we need to handle those. We either need to bring our umbrella or our jacket, but not both. So now we'll introduce an elif statement, which means else if. And we'll say is raining, and now we introduce another logical operator called not. So not, and we put what we want to check inside the parentheses. In this case, is cold. Finish with a colon. So this says, if it's raining, but it's not cold, what do we need to do? Well, in that case, copy this. So in this case, we need to bring only the umbrella. And if it's not raining, but cold, we want to bring our jacket. So let's do one for that as well. So we'll copy this. And this time we'll say it's not raining, so not. And is cold. So it's not raining, but is cold. In that case, we bring jacket. All right, let's try this. So good morning, bring umbrella and jacket. That's when it's both raining and cold. So if we change this to false, so it's no longer raining. good morning, bring jacket. And if we change it to be raining, like that, we should bring the umbrella. And at the very end, we'll make a change so that if it's neither raining nor cold, we'll say shirt is fine. There we go. We run that. Excellent. So we got that to work. Now let's run a short example on doing this with numbers as well. So let's say, for instance, that you're doing a credit card purchase, or rather you're the credit card machine company, and you have the instructions that all purchases under $50 or 50 whatever the currency is don't need a PIN code to be approved. So let's try and write a short algorithm for that. So let's start with an amount, the amount of the purchase, amount equals 10. Then we have an if statement, less than or equal to 50. And if it is, we'll say print purchase approved. Else, we'll print please enter your PIN. But let's try this. So the amount was 10, so it was approved. Let's try the amount 49. Still approved. Let's try 50. Still approved because it's smaller than or equal to. What if we run 51? There, please enter your PIN. And we're done with that. So see you next time. Welcome to this exercise where we're going to build a calculator. So here's the exercise. We're going to create a calculator which handles plus, minus, multiplied, and divided by, and outputs the answer based on the mode or operator used. There's a hint to use 3 separate inputs. And then as a bonus, extend the functionality with an extra mode so it also does Celsius to Fahrenheit conversion. And the formula for that is the temperature in Celsius times 9/5 plus 32 gives you the temperature in Fahrenheit. So give that a shot, and I'll see you in a few seconds after you've tried. Okay, you're back. Awesome. So I hope that worked. I'll give you an example of how to solve this and start coding. So we're going to need a mode or an operator, and we're going to need 2 inputs to be able to add 2 numbers. So let's start with the mode. Mode gets, and we'll use an input. So input, enter math operation, and we'll help the user by telling them what they can use. Multiplied and divided by. And parentheses, colon. And then we need the first number, so num1 gets, copy this, enter first number. Okay, you need a second number, so we'll just copy this. Make that num2, enter second number. Now if we use it this way, we'll get strings as the input, and we don't want that. So let's convert these to a float. Would have been smarter to do it before, but better late than never. So here as well. So whatever's input there will be turned into a float. If they type something, we're in trouble, but let's not worry too much about that. So now let's get into the conditionals. If we start with an if, mode is equal to, 2 equal signs means equal to, and then we'll specify a string, in this case plus, then colon, indent, whatever we want to indent. We want to print. We'll print a formatted string. We'll say answer is, and we'll add the 2 numbers, num1 plus num2. Then we'll copy all of this, down a row, go back, paste. We could use an if, but the difference between using an if and an elif, which is what we're going to use, is that if we run ifs, each one of the ifs will get checked. So first it goes to check if mode is plus, and then if we use an if on the next one, it's going to check that as well. If we use elifs, it will only check until it finds something that is correct. Then it stops and exits the conditional. So that's the benefit of using elifs. So here, we'll say minus, and instead of the plus here, we'll say minus. And we'll copy this because the rest of the statements we're going to use are going to be elifs. So back. Next one, if we have a asterisk, which means multiplied, we are going to multiply the numbers. Great. And then if we have divided by, so divided by, we are going to divide the numbers. Great, that's pretty much done, except we might run into the case where somebody types something wrong, so we need an else to capture anything else. So let's say if anything else happens, we'll print an error message. So we'll say input error. There we go. Now, strictly speaking, if I haven't made any mistakes, this should actually run. So let's try it. I get a pop-up that asks me for the math operation, so we'll say plus. And then it asks me for the first number, 12, second number, 13. That should be 25. Yay, we get 25. Awesome. Let's see if it works with multiplied as well. Let's run it again. We will use multiplied. We will multiply 7 by 9, which is 81, right? Or 63, potentially. 63. There we go. So it seems to work, at least for multiplied and plus. Let's just assume that the other ones work as well. Now we need to add this Celsius to Fahrenheit conversion. We can actually do that in two ways. We can do it in the following way by adding another Elif statement. So Elif, and then whatever we decide it's going to be, like F, for instance. Let's say if they input the letter F. And because people don't know the difference between a shift key and other keys, we will make sure that it's a lowercase. And now it'll work even if they enter a large caps F. But of course we need to capture it as well. So we need to extend our input up here. So we'll say or F for Celsius to Fahrenheit conversion. We've done that. We now need to change the calculation down here. So we are going to use the formula that we have. We'll say num1 times 9/5. We'll put that in parentheses, and we will add 32. So if it gets an F, it should output answer is, and let's change that text as well and say, let's add the num1. Num1 Celsius is equivalent to Fahrenheit. So if we run this, we'll now enter an F and enter a temperature, say 0. Enter a second number. We don't actually need that number. That's annoying. So we'll enter 45. Now we get 0 degrees Celsius is equivalent to 32 Fahrenheit. That's actually correct. But that second pop-up box was a bit annoying. So how do we get rid of that? Well, if we take this term and we'll try to do some coding so that we get rid of the second pop-up. So we'll put that in front of this num2. So here we'll say, now it says Elif, but we're going to say if the mode is lower f, then we're going to print this text. And if it's not, so if we want to use the regular calculator mode, we'll say else. Now everything here needs to be indented. So it's only going to have, so everything needs to be indented. Now the main if that we're running is this one. First we'll check if lower case mode is f. If it is, we'll run this print statement and it's not going to do anything else. But if it's not, it's going to run this else statement. It's going to ask us for the second number, and then it's going to run another if statement to see if we have plus, minus, multiplied, or divided by. And then if there's an error, it's going to give us an input error. So let's see if that works. So we'll say F for Fahrenheit, the first number, which is going to be the only number. Let's do 28 degrees, which is comfortable. So now it didn't ask us for the second number. So it says 28 degrees Celsius is equivalent to 82.4 degrees Fahrenheit. That's kind of warm and nice. So let's try it again. Let's try with the multiplication now. Multiplied, and then we'll take 10 times 20, which should be 200. And it is. So there we got two input boxes, and we got the right number. And we're done with that exercise. I hope you enjoyed it. See you next time. Welcome to this conditionals exercise where we're going to try and optimize a function. So here's the function. So the function is called numDays, and it takes the input month. And based on the month, which is a string, it's going to give us back the number of days in that month. And what we're going to do is trying to make it shorter and more efficient, maybe even faster. We'll look at that at the end. So at the bottom here, we have the instructions. Optimize, shorten the code in the function. Try to reduce the number of conditionals. So that's basically the elifs. So see if you can figure out a way to make this function shorter. And I will speak to you shortly. All right, awesome. Did you get that done? Of course you did. So let's look at one way you could go about doing this. Let's go to the top. So what we see is we have three different number of days. We have 31, 30, and 28. Of course, sometimes February is 29, but let's just ignore that for now. So the first thing we're going to do is try and extend this first if. Month equals Jan, and then we'll use or statements. So the way we'll do that is we'll copy this, and we'll do our line of ors. So we've got month equals, and we'll do the March, or May, or July, or August, or October, or December. So those are the ones that give us 31. So then we can get rid of the other ones of 31. So we'll get rid of March, we'll get rid of May, August and July, October, and December. So that code should work. Let's give it a shot and see if it can find October. Number of days in October is 31. Great, so it seems to work. Then let's do the same thing for the months that have 30 days. So we'll do something similar. This Elif will add or June, or September, or November. Get rid of the last ones here. So already you see our code is a lot shorter. So let's just make sure that it works. So we ran October before. Let's run June. Number of days in June is 30. February, 28. And July, 31. Great. So this is shorter code, but it doesn't look super nice. So let's see if we can clean it up a little bit more, maybe make it more efficient. One thing we could do to make it more efficient is to introduce an else at the end. So let's not even check for these things at all. Let's just get rid of them and say else. We'll say that the number of days in the month is 30. Because if it's not one of the first, that's 31, and it's not February, then it has to be one of the other ones, supposing that we're getting correct data, which could of course be a big assumption, but let's go with that. So let's try it again. Let's ask for June, which is one of those that should be 30. Yep, we get the right result. So now we've skipped one Elif and just used an else instead. Can we make it even shorter or more efficient? Well, we have 3 print statements now. Maybe we'd like to move the print statement to the end. How could we do that? Well, we could introduce a variable. Let's call the variable days. And let's say that it gets 31 as a start. And then in our first if, let's change these where we're looking for one of 7 months. Instead, let's look for one of 4 months. Let's paste in the other ones that have 30. So if it's one of those, we'll say 30 days. Otherwise, it'll be February, and it'll be 28 days. Then we'll get rid of this last bit here. And both of these print statements are going to go. Let's start with this one. And instead, we'll say days gets 30. And in the second one, we'll say days 28. That's for February. Now we have a print statement, which will move out so that it's at the same level as the big if. So that's only going to get printed at the end. We don't want 28. We're actually going to print the variable days. So there we go. See if it works for June. Number of days in June is 30. January, great, 31. And February, 28. So it looks like it works. Could we do anything further to this? One thing we could do is to change these. I'm going to copy this, paste it in again. I'm going to comment out the second if, and let's use a different function. So instead of saying if month is equal to, we'll say if month is in, so that if it's a member of, and then we'll start with a list. So we'll put these inside a list. So what the code is going to do now is check if the string month is inside the list that we've just added here. Let's see if that works. Let's check something for January. That works. Now, we could also use a tuple. That's also going to work. And on paper, that should be slightly faster. And we could also use a set. And because sets are optimized for this kind of membership checking, it's going to be a lot faster. I did some runs on this. I ran it 3 million times, and it turns out that the set is about as fast as running the normal if, the one that I've commented out below. And the list and the tuple turn out to be a lot slower. They actually took about 5 times or 6 times as long to run. So that's something to keep in mind. And this will also work. So there we go, 31. Of course, there are many different ways you could change this code to optimize it. I've probably only touched the surface on it. I'm sure there are some people out there who could make this code blazingly fast and super, super duper short. But with that, I'll leave you for now, and I'll see you next time. Whenever you see repeated code like this, as a programmer, you should immediately feel an urge to optimize the code and say to yourself, I wonder if a loop would help here. The answer is almost always yes. You'll find that programmers in general are pretty lazy people, and doing things over and over again just isn't in line with being lazy. So less keyboard strikes, always better. And if you react by deep frustration when you see this, then you're definitely programmer material. Go you! So, loops, what are they? Well, they're code that runs again and again until some condition tells it to stop. Loops are absolutely fantastic for doing things that would bore humans to death, like perhaps checking a list of 5 billion emails for some particular word, which naturally nobody does, since where would they get all the emails? Let's start by looking at while loops, because what we have on the screen right now is not awesome, and awesome is our goal every time. So the first problem we have here is that we've written out some text, and it's the same text, and if we want to change something, we have to change it in all the 5 rows. Now we have 5 rows, so that's not too bad, but imagine we had 5,000 rows, and there were some small differences. And here we can definitely see a pattern, right? Because we're typing the same text, and we have 1 star on the first one, 2 stars on the second one, 3, 4, and 5. We also see the counter here at the beginning, 1, 2, 3, 4, 5, and we can see a pattern there. To do this, we'll use a while loop. So how do you write a while loop? Well, the syntax is really simple. You write while, and then some condition, colon, then you indent whatever the code is that you're going to run, and then probably you have some iterator or counter that you're going to increase or decrease or whatever the case might be, and then you're done. So every time you want to use a loop, you want to ask yourself 3 questions. We'll call them the 3 loop questions. And they are the following. What do I want to repeat? What do I want to change each time? And how long should I keep repeating? So in this case, what do I want to repeat? Well, the message. And what do I want to change? The stars. And how long should we repeat? 5 times. Okay? So those are our questions and our answers. And we'll start by creating a variable, which is the counter or iterator, which is generally labeled I equals 0. And then we'll write a condition, and the condition will be while I less than 5, we'll run some code. And the code will be print loops are awesome. And then iterator, we haven't talked about that before, so you're probably wondering what that is. That's where we take the number I, which we're checking at the top, and we're changing it. So we'll say I equals I plus 1. But what's going to happen here is that the while loop will start. So the first time the program comes down here, it will check if I is less than 5, and I has started out as 0. So it's less than 5, it will go into the loop, it will look at the first command, which is print, loops are awesome, and then after it's printed that, it will go down here and see, ooh, I need to increase the number of I to I plus 1, so it goes from 0 to 1. Then it goes back to the top and runs the loop again. So then it checks I, which is now 1, still less than 5, runs through the loop again, comes down to the bottom, increases it by 1, now I is 2, goes up to the top, I is now 2, it checks it, it's less than 5, continues down, and it does that until it comes up here and it's 5. So I is now 5. I is now no longer less than 5 because it's the same. So it will not execute anymore. It will just leave the loop and continue down. That's how the loop works. So let's start by running this code and see what we get. So now we're printing loops are awesome. That's great, but we haven't got the stars yet. So we need to format our print statement. So we'll use a formatted string for this. So we type an F, then we use the I, period, and a star, and at the end, we'll put a star. Let's run it again. So now we have a counter, but it's starting at 0, and we only have 1 star on either side. What do we do about that? Well, let's format the string a bit more. Let's go in here, and we'll concatenate, enclose the star in quotation marks, concatenate that with the rest of the string, and then we'll multiply this by I. So we'll multiply it by the iterator, which will take on a number between 0 and 5. And we'll do the same at the end. So we'll say quotation marks plus times I. Now we'll run it. There we go. Now to get some more space, let's remove these old print statements. Run it again. Now we're getting somewhere, getting close. So now we're getting 0 at the top. We're getting 0 stars and the number is 0. So we could change that either by starting with a higher iterator. So we start at 1 and end at 6. Or we could move the iterator. So we could move the iterator in front of the print statement. Then we'll get the counter increased before. So we'll increase the number 0 here to 1 and we'll put 1 star in here. So let's run that. See, now we're getting there. Now, I told you before that programmers are lazy, and iterators are used really, really often. So there's shorthand for writing iterators. And the shorthand for this particular iterator is to write I plus equals 1. Now, in this case, the syntax is take I, add, because it's a plus sign, the number 1 to it. each time. So if we had a multiplication here, it would multiply by 1 or 2 or whatever the case might be. So this is the syntax. In a lot of other programming languages, you can write it even shorter. You can write I++, and that's the same thing as saying increase the number I by 1, but not in Python, at least not yet. So I plus equals 1. Run that again. There we go. And then just to show that you can use multiplication, we'll increase the number of stars at the end and multiply it by 2. Now we get more stars at the end. That's an introduction to while loops. I'll talk to you next time. In this exercise, we are going to build a guessing game. So here we have some instructions. Guess the correct number in 3 guesses. If you don't get it right after 3 guesses, you lose the game. Then we need to give the user an input box to capture guesses, and then we print or use input boxes if the user wins or if the user loses. And then there's a tip, and that's really that in Scrimba you won't see the prints that you make, so that's probably a good reason to use the input boxes to output data while the while loop is running. And then as a modification, try to use the number 1 to 100 and then tell the user if the guess is too high or too low and let them have maybe 5 to 10 guesses. So there we go. And maybe the first thing to take a look at are these 3 loop questions. What do I want to repeat? What do I want to change each time? And how long should we repeat? So take a look at this and I'll be back shortly with one example of how to solve this. So I would love to see the code you've just written, and I'm sure it worked. So let's take a look at one way you could solve this. So let's start with the questions. What is it that we want to repeat? Well, we want to repeat the guesses. So we want the user to guess a couple of times. What do I want to change each time? Well, the guess number. And what else? The number of guesses the user has taken. And how long should we repeat? Well, until user loses, or runs out of guesses, or wins, right? Those are the things that we want to look for. So with that, let's get cracking with some code. So the first thing we want to specify is a number. So let's just call that number. So that's going to be our secret number. Let's call it 12. And then we're going to make a guess. We can start that number with 0. So that's the number that we're going to be guessing. And then let's say we have a guess limit, which is the maximum number of guesses our user is going to get. So let's say 3. And then the current guess number, which we need to keep track of. So let's call that 0. All right, so now what are we going to do? Well, we need to create a while loop that loops until the guess number no longer is less than the guess limit, right? So the number of guesses the user is going to take needs to be less than the guess limit. And as long as it is, they can keep guessing. So let's say while guess number less than guess limit. We are going to do something. What are we going to do? Well, let's ask the user for a guess. So let's say that our guess is equal to, and we raise an input box where we say, guess a number 1 to 20. There we go. And what's this going to be? Well, when we use an input box, we get a string, right? And we don't want a string. We want this to be an integer because we're going to be comparing it to things. So we cast it into an int. And then let's say that the user guesses the right number. So if guess double equals, which means equals, num, our secret number, then we're going to do something. What are we going to do? Well, let's print that they won. So we print, use a formatted string, and we'll say, you win. You guessed it. And let's put the guess in there so they know which value it was that was correct. Finish off that. Okay, and if that happens, we want to break out of the loop. So we enter a break. And else, so if they don't get it right, we want them to guess again. So then we'll print, no, not, and then again the variable, guess. And then we also need to increment the guess number. So guess number plus equals 1. We add 1 to it. If we leave the loop, so if the guess is not equal to number, and the while loop is no longer active, so the guess number is now as big as the guess limit, then they lose, right? So if we say if guess is not equal to num, then we print, sorry, you lose. And let's input the actual number that they were supposed to guess, which was num. That looks a bit weird. In fact, let's make that a bit more interesting. Let's say f, the formatted string. This should also be a formatted string. So let's also tell them what the guess number is. So we'll say guess number And let's see if that works. And then let's tell them what their last guess was. So last guess was guess. And then colon to make it more readable. There we go. Let's see what happens if we run it. Ah, I get a pop-up box that you don't see, so you can run it on your end as well. So let's enter a number. I'm going to guess 11. Ah, it asks me to guess again. I'm going to guess 13. Still not right. That was guess number 2. And then I'm going to guess 12. There you go, I guessed it correctly. So no, not 11, no, not 13. You win, you guessed it, 12. So one of the things that can be tricky in this is to keep track of what the number of the counter is. So when we enter into this while loop, the guess number is 0, and it doesn't get updated until here. So as long as I'm in here, it's still 0, and that's why it's outputting the wrong number here. So I actually need to raise this by +1. You can try this on your own and see what happens. So let's try it again. Let's see that it works if I don't get it right. So now I'm going to guess 13, 14, and 15. See, now it said, sorry you lose, it was 12. Great. So now let's try and extend this thing. Let's try and add that part where it gives us some more information if we guess too high or too low. So what were the things we needed to do? Take a number between 1 and 100, tell user if the guess was too high or too low. So we need to make some changes here. Let's change the number to, say, 76. And now we're going to allow 5 guesses, and we still start at 0. So the first thing we want to check is if they are wrong, because if they are wrong, we want to go in and show them if they're too high or too low. So let's start here and say if the guess is not equal to number, so if guess not equal to number, then let's update the guess number here. Guess number plus equals 1. And then so if their guess is higher than number, then we let them input a new guess and we tell them that their guess was too high. So guess gets guess again 1 to 100. And if that's not the case, so else, we can paste in the same thing, but now we have too low. So that should handle the higher and lower. But the first time they guess, we want to give them the generic guess. So that's sort of this one. Let's cut that and put that before the while loop. And let's change it slightly. Let's just say this is the first time they guess. So guess a number 1 to 20, and they haven't guessed before, so they don't have a last guess. So we come into the loop. If guess is not equal to number, because we have captured the guess here, we increase the guess number by 1. And then if the guess is higher than number, we say too high, guess again. If it's not, we say too low, guess again. And then we need to change some stuff down here. So we can actually keep this. If guess equals number, then we print you win, you guessed it. So we can leave that. This else statement, we don't need anymore. And then at the end, when we break out of the while loop, if the guess is not equal to number, sorry you lose, it was this number. So I hope you understood why we broke out the guess outside of the while loop, and that's so that we capture it the first time outside, and then we do the higher or lower inside the loop. Now this actually gives us quite an interesting learning experience, because when we break out the first input box, you'll see that that's the first guess the user gets. And then we run the loop, giving the user another 5 guesses. So that's 6 guesses in total. That's not what we want. So we need to do something about that. What could we do? Well, the first thing we could do is change the guess limit. So we could change that to 4, and that will now give us 5 guesses. 1 guess before, and then 4 loops. So that's 5. That's not really intuitive, because we have a guess limit of 4, but we're saying that it's going to be 5 guesses. So somebody who reads the code after us might not find that very intuitive. So let's leave that at 5. Another way we could do this is to change the while loop so that we actually change the counter. We only count up to guess limit -1. So it's not going to count to 5, it's going to count to 4. That's another way we could do it. We could do it another way. We could initiate the guess number to 1, that way stripping away one of the while loops, right? And in the same manner, we could actually take this bit and we could put that either above or below. Below seems a bit more intuitive. Put it all the way in. Of course, then we don't want this to 1 anymore, we want it to 0, and we could increase the guess number by 1 after our first guess. That way, the code will run the way we want it to. So if we increase this to 100, like that, and we try running our code, I get an input box. So I'm going to guess, let's guess 20. Too low, so guess another one. 40, still too low. 60? How about 70? That's guess number 4, so this is my last guess. 70 was too low, so let's guess 77. Oh no, I lost. So at least I got the 5 guesses, which is correct, right? So I hope you enjoyed that, and again, realize that almost all code challenges can be solved in many different ways. So I'll see you in the next cast. So previously we covered while loops, and this tutorial is about for loops. For loops differ from while loops in that you'll generally know the number of iterations a for loop will perform beforehand, which isn't always the case with a while loop. Most of the time, for loops are used for looping through all the letters, all the objects, members, or whatever in a string, list, or something else. They're really awesome for that. A deep understanding of the difference between for and while loops is sort of optional, but the most fun and memorable way I'm aware of is the push-up analogy. It goes like this. Imagine that you're in the military and your drill instructor or drill sergeant often hands out, let's say, motivation in the form of push-ups to be performed, like drop and give me 20, which means that you need to get down and perform 20 push-ups. Now, this type of order can be viewed a bit like a for loop because you know in advance how many push-ups, loops, you need to do, and when you're done, you can stop, exit the loop. Generally, at least. Sometimes, however, you will be told by a drill instructor to do push-ups, which means you keep pushing until your instructor is happy, which could be a while. This, I'm not sure how many I need to do, so I better check if I should stop or continue after each push-up loop can be likened a bit to a while loop. Now, I really wish I'd come up with that myself, but I haven't. Credit goes completely to a guy named Baron Stone's YouTube video. Thanks, Baron. And now, let's take a look at some different for loops. So let's start with the syntax. So here's a for command, and we'll go down a row, and we will indent this command. We'll move the next one down a row, and we'll change this to letter. In the command, we have the for word, which is the command. Then we have a variable called letter. You can call it anything you want, and what it does, for makes this variable go in through each one of the atoms, let's call it, of this string, or a list, or whatever else it is, and pick up each one of them. So the first time it will pick up the N, then the O, then the R, and so on. So let's run this and see what happens. So here we go. So it's going to print out Norwegian blue. And again, as one of these oddities with the Brython Scrimba thing, you see that there's no space printed out. For some reason, it skips spaces. Normal Python doesn't do that, but in this environment, it does. So you see we printed that out. And if I wanted to, just to prove this to you, I could call this a fergle. Of course, I would need to call this a fergle as well, so that you believe that you can actually call these things anything you want. And I'll get the same result. Okay, so what else can we try and do? Well, we can use ranges. A range is a really useful tool when you want to pick up different numbers. So we can say for item in range, and let's say 8. This means that we will take all of the numbers from 0 up to 8, but not including 8. So let's run that. Now we have 0, 1, 2, 3, 4, 5, 6, 7. You can modify this command and say starting from 2 up to 8. So this will then start at 2 and run to 8, but not including 8. So now we have 2, 3, 4, 5, 6, 7. You can also use a step. We could start at 1, we could run to 15, and we could do in steps of 3. So we then get 1, and then we have a step of 3, we get 4, step of 3, 7, 10, and 13. We could also do this in a list. So let's add a list with some names. Let's do John, Terry, Eric, Michael, and George. And let's change the fergle to be name. Not that it matters, but just to show you that you can call them useful things, because these are names, so that makes sense. And of course, it's not a range. Sorry about that. Let's remove the range, run it again. So there we get the different names. We could move these names to a variable like this. So we'll grab that, and we'll say we have a friends list equals that, and we'll say for friend in friends, print friend. And we get the same loop. In this case, it's looping through all of the different items in the list that we have. We can also specify the number by finding it out by using the length of the list. Instead of doing it this way, we could say for index in range. So now we're going to specify a number, and the way we're going to specify the number is getting the length, len, of the friends list. So now it's getting a number, which is going to be 1, 2, 3, 4, 5. And then we want to print, we don't want to print the friend anymore. Now we have to specify what to print. Friends, and then the index. And so we'll run this, and you get the same list. Great. So now let's remove this length counting and let's look at two statements, the break and the continue statement. The break statement takes you out of a loop, and the continue allows you to continue when something happens inside your loop. So I'll show you an example of how to use these. So let's say again, for friend in friends. Now inside the for loop, let's specify a conditional, an if statement. So here we go. We'll say if friend is equal to, i.e. is identical to, Eric, then we'll do something. And what are we going to do? So we need to indent what we're going to do. Print found, and then what we found. Friend plus exclamation point, like that. And then we are not going to print the index, but print the friend. That's outside the if, inside the for loop. If we find the friend, we're going to break. Now this is going to break out of the loop. So let's give this a shot and see what happens. So it finds John, Terry, and then it found Eric. Okay. And then it jumps out of the loop and it goes down and prints the for loop done. Okay. What if we use the continue statement? If we run with continue, it finds John, Terry, found Eric, then it continues with Michael, and then George, and then the for loop is done. So what it does here is when it hits the continue, it goes back up to the top of the for loop. Now that's different to if we remove it completely. So now we have neither break nor continue, and we run it. Then we see we have John, Terry, found Eric. Then we have Eric again, Michael, and George. That's because when it finds Eric, it then continues inside the for loop and runs the print friend, which is Eric, which we just printed found friend, because friend is still Eric. Okay, great. So that was break and continue statements. Those are good to keep track of because you can use them for different things when you're controlling your code. The last thing we're going to cover are nested loops. And a nested loop is basically a loop inside another loop. So I'll show you. So what we'll do is we'll exchange this for a for loop instead. So we'll put another for loop inside the first loop. And we'll say for number in, then a list, 1, 2, 3. And we will print friend, comma, number. Like that. We'll remove this. And we'll remove two names just to make the printout a bit shorter. So what's going to happen here is that first the top loop is going to run. So we'll go and find John, and then it finds the next for loop. So it goes in, and for each one of the numbers, 1, 2, and 3, it's going to have John as friend, and then it will run numbers. So it should print John 1, John 2, John 3, then go up and get Terry, do the same thing again. And I should not forget colon here. John 1, 2, 3, Terry 1, 2, 3, and Eric 1, 2, 3. For loop done. And that's it for for loops this time. Hey, welcome back. It's great to see you again. It's awesome to see that you've gotten this far in your Python programming, and I'm sure you feel that you've learned a lot because you really have. So let's get started with this for loop exercise. Let's take a look at what we need to do. We've got two lists. So we need to make party invitations. So we're going to have a party and we want to invite our friends. We want to print out invitations for each friend using for loops. Okay, great. So the names are in two lists, names and names1. We also need to add two extra names to the list using an input box when we run the code. So when the code starts, we should see first one and then another input box where we can input a new name. Print out one invitation for each friend per line, and names should be properly capitalized. So the first letter of each name, first and last name, should be a capital letter. And here's an example of a printout. Okay. And then we may need two for loops to solve this exercise. So that's the exercise. You know how to do this now. Just pause me and we'll make this thing small again. And then just get coding, try it out, use print to debug your code, and then come back to me in a few seconds. All right, welcome back. I'd love to see your solution because I'm sure that you've solved this very well. So let's take a look at one way of doing this. So first, let's just write part of the message that we're going to use for all of the people. So let's call that message. Message, and let's say something interesting like, you are invited to party Saturday, period. So that's going to be the text that all of the friends get. Next thing we need to do is combine our two lists because we've got two lists of names and we want all of them to be in the same one. So we can do that in many ways. I'm going to show you two. The first one, let's just extend names. So we'll say names, extend with, what do we want to extend it with? Well, names1. That will create a new list, or rather it will extend names with the contents of names1. So we get one long list that contains all the names. Great, so we've done that. Another way we could do this is to say names gets names plus names1. And we're going to start with the top one. So then we'd like this input box. So let's just start with an input box. So input, enter a new name. So where do we want this new name? Well, we want to append it to our names list, right? So let's say names, append, and we'll put that inside parentheses. There we go. And we want to do it twice. So we'll need a for loop or another loop. So we'll say for index in range. Let's say 2. That means we're going to run through the numbers 0 and 1, but not 2. And then we need to indent this, and that should give us the 2 input boxes. So that's great. The next thing we want to do is print out the actual invitations. So this time we want to run through each one of the names in our new names list and the 2 added ones we've just made. So for name, and the name is just a temporary variable that I can call anything, in names. That's the actual name of the list. So that means it's going to iterate through all of the items inside the names list. New line. Let's create another message. We'll say message1 gets, and we'll use an f string because that feels like it's best practice. So the first variable we want to use is name, right? Then maybe an exclamation point, a space, and then the generic message that everybody gets. So message. Then we want to print this. Here we go. Let's give that a shot. We get a pop-up box. We'll get our first person, John J. and Jamie Lee. So there's our printout. 1 row for each person, and we have John J. and Jamie Lee at the end. Looks like it's printing out well. And Terry here only doesn't have a last name because he doesn't have a last name in the names1 list either. But they aren't very well capitalized, so we need to handle that. How do you do that? Well, let's go to the name here, and let's title. So using the method on the string called title, that's going to capitalize the first letter of each word, which is what we want for a name, right? Let's try it again. Get a pop-up box, John J. and Jamie Lee. Now that looks a lot nicer. Now let's take a look at the names up here. Now we'll uncomment the second one and comment the one we've been using and run it again. So John J. and Jamie Lee. Again, it works. Now let's try this instead. Do you think that's going to work? Let's give it a shot. John J., Jamie Lee. That works too. Great. There's one other way we could print, of course, using a normal concatenation and not an f string. So we could say message1 gets name, title, plus, we'll insert our exclamation point with a space, plus message. We'll comment out the first one, run that, pop-up box, John J., Jamie Lee, and look at that. That worked too. So we managed to solve this birthday invitation, or at least party invitation. I don't know if it was a birthday. I hope you enjoyed that, and I'll see you in the next tutorial.